Start. Okay. So now, just a real quick review. We talked a little bit about, some of the settings, some tools like, erase by closed polyline. We learned the Carlson draw 2D polyline tool and the point snapping. Learn about point groups, and that's I guess sort of a good foundation that we did. We learned about the object linking and what happens when linking is on, and when and where you might want it on or might want it not to be on. It just depends on your needs. So just to understand what's happening when it is, and also to understand that you don't have it on, you do something. If it was created when linking was on, and then you just go up and uncheck that box, and then it doesn't make that thing unlinked, it would either need to be redrawn again, or there's another command you can decouple the it's called the extended entity data from those things, but it sort of leaves things orphaned. It's usually easier just to redraw whatever you created that previous time if you need it to be unlinked. So so what we want to look at next is this idea of modeling surfaces, of terrain modeling. And now let me ask, you guys are probably both at least passingly familiar with generating a surface so that you can draw your contours and things like that. But if not, let me know what, like, the concept of, what creates a terrain model, the fact that it's all of these triangles that are joined up edge to edge. And that basically, all of those triangles that form by attaching points of a triangle to the points of nearby drawn three-dimensional features in your data. And it's those triangles in between the points that carry the elevation into those empty spaces. So you then have a contiguous stitched together surface, and you can then query that surface in between those items that had data that created the surface, and you can see what that surface is interpolated to be. And that's all it is just a straight interpolation along those triangles that form the gap, that fill up the gap between those features. Now, you can read a bit about some of this concept here in the manual. It starts on page 18 and talks about terrain modeling, how well it, or what it came from, how it worked, and the fact that we in our particular profession are really sort of geared toward understanding contours. We can look at a contour map and understand exactly what that land is doing based on that. Now, we usually need to know, are these contours higher than those contours or lower than those contours, so we know whether it's a ridge or a valley or a hilltop or a pit. But once we get that idea, we can figure it out. We know how they work. Now, that's good and it's bad. The good part is that, it lets us work with drawings in the format that they're typically delivered. And we know, what would make a good indication of surface for that. The bad part of it is this: from years of contour maps being our only source of data for a particular piece of ground, we've come to think of those contours as absolute, and they're not all those contours are a sort of snapshot interpretation of the underlying ground surface. Now, that means whether you draw it with a pen on a piece of paper, or you use a plane table and an alidade to gather the data from the field, none of that matters where it comes from. But what those older style contour maps are saying, and all that they can say, is that This is what we think the elevation is here along this line of constant elevation, what a contour is. Now, the shapes of contours, like the noses that, oh, you know, if you got contours going on, then they form a nose pointing in a certain direction. We know that in valley shapes, the contours point up the hill. Ridge shapes, they point down the hill. So, you know, we have a sense of what happens there, but the computer doesn't know what happens in between there, because when you tell a computer to go make a surface out of that, it's going to walk along every point, every vertex of every contour line. I'm talking about the instance of when you make a surface out of a contour map as your only elevation data. So it's going to walk along every vertex of any given contour, and it's going to look around itself in 3 dimensions, and it's going to start connecting lines to form triangles. It's going to draw lines out to everything it can find, as long as there's not a line in between where it's sitting and where it's looking. So if another triangle from a previous operation has formed next to it, or, you know, in proximity, the edges of triangles then act as barriers that it can't see past, so it won't jump across and have those overlapping triangles. Well, the problem is with things like those nose-shaped valley contours that we're familiar with just inherently, the computer doesn't know any better, and it gets in there and it starts walking that contour line. And then when the contour shifts and runs up into that nose shape, the closest contour line, or the closest points that it can find for anything in the drawing, it starts looking across and sees itself on its return trip back down out of that peak. And it sees those points before it sees the lower or higher contours, the next one up, the next one down. And so that's what happens, is it fills in those triangles from where it sits, starts creating triangles then across to the points it sees on itself. So that means it's the same elevation, and it fills up that entire space in that little nook with contours, or with triangles that are all the same elevation as the contour line. So mathematically, it's perfectly correct. But we know inherently that, no, if I start at this point and walked across the ground that is contoured the way I see it here, go to the other side, I'm not going to walk in a level line. I'm going to walk down to the bottom of that little valley, and then I'm going to walk back up to get back to the starting elevation. So it's things like that that we have to know how to handle, and there's various tools and techniques. The most sure way of doing that is we'd have to draw in the 3-dimensional line, the feature that represents the bottom of that little valley. Okay, and you may or may not know what it is, and you can still interpolate it if you go from the tippy top peak of the crest of one contour, you go down to the next contour and connect to the crest, so that halfway between the 2 crests is the halfway elevation point, which would previously have been created on a contour, or on a triangle, from one side straight across to the other side as the same elevation. So you've now successfully created something down there that is, you know, half the contour interval different from what it is when it's level. So that's one way of doing it, but you don't have, you know, there's not enough time to sit there and draw the contours, or the barrier lines, or what we call break lines, down the noses of those valleys and ridges. So we have other controls. They're not foolproof. So, and every software package has those, and I'll show you where they are in Carlson. We have one in Carlson. It's called Minimized Flat Triangles. And then it can also try to recognize implied break lines. In MicroStation, you tell it, and then this is also true in Civil 3D, when you tell it to build a surface using this set of contour lines as a data source, you tell it that what you're bringing in are not just random shots or break lines, you're bringing in contours, and that tells the algorithm hey, be on the lookout for flat triangles and don't create flat triangles. Do everywhere else until, try your best to form a triangle somewhere else until you have to go across and see the vertex on the other side of your same feature. So those are things that, no, the only ones that really works close to perfectly is the Open Roads software, the MicroStation based modeling that I've seen. Civil 3D does okay. It still misses a lot of them. Carlson's does even less than Civil 3D does in terms of successfully. It still does better than if you don't turn the switch on. But so that's all to say that creating a surface from a bunch of drawn polylines is the worst way to do it. It's like taking a copy of a copy of a copy. You keep losing information because those contour lines came from somewhere. And in today's day and age, most likely they came from somebody else running a model, building a surface and generating those contours. And then all they send you are the resulting contours. Well, that's all you've done is sampled that surface along that location, and you know nothing about the surface in between the given contours. The assumption is, and the only assumption you can make, is that it's a straight line change in between. So that's sort of how we start to lose data. Now, nobody really teaches that concept. Even the Civil 3D training data sets use a bunch of surfaces that were built that way, and they're not very accurate. Are they accurate enough to do a county-wide hydrology drainage study? Yeah. But are they accurate enough to put on a bulldozer for grading purposes so it goes up there and grades everything ready for steps and curbs and sharp edges? No, they're not. So you have to know how these things are built. You have to know when and where to use brake lines when you don't need them, and what are some of the best practices on getting that accomplished. So let's take a look at and I would recommend that you, when you get a chance, read the stuff on page 18. I'm not going to read this to you. That's rather insulting. I'm just going to go to these things, but I do want you to read it if you're not real clear and comfortable on the whole idea of how surfaces are formed. And there's even a joke or two in there somewhere, I'm sure. So, but we're going to talk about how triangles form. And if you look at this little picture, disregarding the lines drawn there at this moment, and we see that we got 4 points. Or let's say our surveyors go out there and they shoot these 4 points on the ground. They bring those in and say, hey, here's your topographic information. Build a surface. So, well, okay, I've got 1 point that's at 100 feet elevation, one's at 110, another at 100 and 110. So this can form 2 different ways when it starts to draw triangles. It can draw the way you see it there, which the feature that is derived when you're looking at the data with the triangles forming in this fashion is you have a ridge top crest running between 110 and 110, and it falls away on either side, left and right, to the 100-foot lower spots. Okay. Now that is just as likely mathematically to form this way. The computer could go in there and all it sees are the 4 points, and it can say, well, I'm going to do this one first. I'm going to sit here at 100, look at 100, and then I'm walking. This is like the bottom of a valley, and up on this side, I've got a point up here in the higher at 110. I go up to a point higher at 110 here as well. So that forms like the bottom of a valley. Whereas if it forms this direction, like you saw, it would form a crest where these things fall off. Now the points never change. It's not changing the points. It's just going to change the orientation of those triangles, which affects the way water runs off mathematically and all that. So we need to know when and where we need to put things in there. So if what we have is truly a crest, a ridge line, and not a valley, then what we have to do is, before the computer starts to do the triangulation, we have to draw that line in between from 110 to 110. And if that's in place, then when the computer gets a hold of it and it gets on point number 100 and it looks all around itself, it sees 110, fine, it creates that. It sees 110, it creates that. But it can't see this point over here because there's a line in between it. There's a barrier that keeps that from seeing across that barrier to connect to that point. So it continues to look all around in this area to the east and south. It just can't see past that edge right there if the edge is already there. So that's what we call a break line, because it, and you'll hear them called that because they form along breaks in grade. Well, I never could quite grasp that concept. If somebody had just simply said, these are edges out there on the ground, I would have understood it a lot better when I was going through my school days. So, you know, like it says right here, break lines are nothing more than edges in the surface that you're trying to model. And here's the rule of thumb, particularly for the survey folks and the field crews, is that the rule of thumb is simply this: if it's an edge out there on the ground, we need to make it into an edge in the computer before we say triangulate and contour. Now you can add them to that data later after the fact, but you know, if it's there beforehand, then that's the most accurate way to bring that information in. Okay. And you can see how, here's my favorite example to talk about break lines. You can see how here's a bunch of points, and I've known surveyors that will survey this way. They'll go out there and they'll shoot 1 billion points down a curb structure. They'll get the back, they'll get the top, they'll get the face, they'll get the gutter line or the edge of pavement out here. And they'll just do all those. They'll take 1, 2, 3, 4 shots. They'll go up a few feet, take 1, 2, 3, 4 shots. And yeah, it's kind of rapid, but you can create this thing with, you know, taking one shot on the edge of pavement here and going however far down that pavement you need to go to where the pavement either changes horizontally, you know, there it starts to curve, or it's in a sharp bend, or if it starts to change vertically abruptly, you know. So if it's a linear change from one shot to that, that's all you need to do. And if you draw that line in there, then you eliminate these points on one side from looking to the other. You do the same thing on here on, let's say, the back of the curb. And if it's a standard curb structure and it's uniform, usually what we will do is we'll just shoot the gutter line. We'll shoot the flow line down here because that's what we're usually most interested in terms of our drainage design. So I'll shoot that flow line along that gutter. And if I measured, I know it's a 6 inches up, it's 6 inches across the top, and it's an 18-inch apron on the gutter back here. Of course, I usually also shoot these edges of pavement, but I can take the resulting line down that gutter flow line and I can say, okay, I want you to copy that, go up 1/2 foot, and then copy that one over 1/2 foot. And that builds my structure. Now, is that really what is exactly out there? No. To get that, I do have to, you know, shoot these points along each of those edges. Like points C and D would be all I would normally shoot, and then recreate these other lines. But if I, especially like, see, BB, I was talking to you earlier about when I was training those guys in New York about, you know, getting some of this survey done. They said, yeah, there's no such thing as a standard curb here in our city, because they said they'll, you know, trucks run over them, break them, they're broken down, they repave the road, everything is just a real hodgepodge. So they're in the habit of, and probably rightly so, making sure they physically observe not just the gutter lines, but also all across the top of the curb, all across the back of the curb. And that's fine. But you only still need to get the points where they change. You don't need to get it every 5 feet. You can if you want, but that's just more time. But this trick is, though, once you get those points, you've got to connect those dots. you turn that into something that the points on the other side won't fit, because here's what happens if you don't. Let me get to the right picture. So in this particular case, let's say we don't draw any lines. All we have are the points. Well, the computer is free to sit on point A and look all around itself and start building triangles. Well, it sees point C. Well, that one's okay. It sees point B. That one's okay. But it also can see point E. That is not okay. That tells the computer at this point that the elevation of my model, my terrain, goes from point A and a straight line change up to point E, and it doesn't. It needs to go down here and hit this flow line before it goes up. You guys see that whole concept, I'm trusting. Same thing, G can't see C, or shouldn't be able to see, but is free to without drawing them. But if we draw these lines in, these edges, if I draw in that flow line, if I draw in the top of curb and the back of curb, then the only way point A can start to connect triangles to look around itself. It can't look past that line that we created as a break line. So it can see point C and it can see point B, and those are fine. It can see other points in this direction, even some over in this direction, but it cannot see point E or point G. It can't accidentally go there and start to make triangles that go over to that area. Same thing if we do across the top of the curb. G cannot see C, F cannot see B because of the front. H can't see D or B, but it can see F and G. And those are the ones we want. We want those valid triangles. Okay. So that's the basics of what we're talking about, is knowing that the computer is going to start to build triangles based on point locations, and that is any kind of points, be they CAD points, Carlson points, which contain points in them, contain CAD points in them, but any kind of vertex data in the line work that we select as well. And there are switches in the software that can tell it to, we can leave everything on and still select it, but if it's at 0 elevation, it's going to be ignored. So we have things that tell it to ignore zeros. Okay. But everything that we gather up that it's going to be using to build that consists of all of those points and all of the vertices of any of the drawn geometry that has elevation, whether it's 2D or 3D. A 2D elevation element like a contour line, as long as it's a non-zero elevation, still has elevation. So it reads every single point along there and makes triangles for it. Okay, so what we typically do, is that we need to know how to go to the field and survey it efficiently so that we get only as much as we need, and we're not spending 5 days out there getting stuff that we could get done in 2 days if we were a little more efficient about it. And there's, that just comes with experience and knowledge. But we also want to come back to the office, and we don't want to spend 3 days in the office playing connect the dots, to try to figure out what we need to draw those lines between. We can have the computer do that for us through a process called field to finish. And that's in the survey software. We also looked at it a little bit in the draw locate points default settings down at the bottom, where you could assign a field to finish code table to tell it what symbol and what layer to put a point on. But the survey side field to finish will actually create all of that line work. In fact, it would create based on a code on the points. If I had those points C and D up here, I could have it construct that entire curb structure in 3 dimensions in my computer, just have it do that automatically based on wherever, whatever description that will match a code along with some other controlled information. So if I bring that in, I shoot 2 points instead of 4, 6, 8 points to define that little piece of structure down there. Okay. So that's what we're after ultimately, is better efficiency and less work to have, and less guesswork, so that we do it out in the field before we ever come in with it. So those would be my recommendations. I've seen some surveyors that will quite often they'll do this business of shooting the flow line, and then they go back and they shoot the back of curb only. And and then they'll make a note that, hey, it's a 6-inch square curb. Whereas if the computer doesn't see that line across the top edge of the curb, it thinks it's a triangular wedge curb, because it only knows about that line, and it knows about this black line, this back line. Well, I've seen, some guys out in the field, they'll say, yeah, but you know what we mean. Well, yeah, I know what you mean, but the computer doesn't know what you mean. And we need to either have you observe that edge, or somehow, it's some instruction either through the field to finish process, or have you draw a line that's 6 inches over, and making sure it doesn't overhang the front line. So anyway, those are nuances and speak to truing up the data. Now, a couple of other things that might be an interesting read is, where can we get data? Where does our data typically come from? When what we do, it's almost always field survey. We get points that are going to generate that, but you can model anything. It can be, like I said, right here, population density, temperature variations, etc. All you have to have is a set of data, and it can be turned into a surface. Here's an example, say, of a DEM data that's generated from a USGS quadrangle. And those are on 30-meter grids. So about every 100 feet, they're giving you the point elevation. Well, so from 35,000 feet, that's perfectly fine. But if you need to have that curb in a set of steps, and something that's abruptly changing, if you need that part modeled, you're not going to get it with that kind of data, because you don't know what happens in between those points that are 30 meters apart. So you need to have a little finer source of data. And the key thing is this, and here's our typical set of sources, different ones. But right here's the key, is that we need whatever data we're using, we need to evaluate that data, make sure that it is suitable for our purposes, make sure it is correct. Okay. Whether that comes from a LiDAR point cloud of millions of points, or if it's from a survey data collector, or if it's from a table of DEM values. Whatever it is, we need to assess it and assess its quality. And we're going to do a lot of that stuff visually. We're going to turn the view up in a 3D viewer and look to make sure things look like what they are. So for instance, if you look at this data right here, this is in plan view. I'm looking straight down on it, and I see this red is my driveway. This black heavy line out here is my main road. And these little squiggly lines and little X locations, those are brake lines and spot elevations. This data was, and this is real data, by the way. It was compiled by a photogrammetrist of a particular parcel. Now, what you'll get when you look on this in plan view, you don't know anything about that. You don't know that these are 3-dimensional lines. You don't know that those spots have elevation, and you don't know whether or not these road edges and driveway edges, which should be at elevation and acting as brake lines, you don't know that they are or not. They could be, and sometimes they are in a situation like this, where this is what you're expecting, but this is what you're getting. You're getting all of these brake lines correctly at elevation, but all the road edges, and maybe see there's a stream center line that runs down that little valley stream up here. Maybe they're drawn at 0 elevation, and they're just in there to graphically indicate it. So when you turn this up and you see that, you go, oh man, well, that needs to be at elevation. Well, there's an easy way to fix that, but you need to know that you need to fix it. But there's some tools to take that stuff and drape it onto either of these three-dimensional objects that it would hit, like up here, or after you build a surface without those break lines, then you go back and take those edges and drape them on that surface and then add them as break lines into the surface, and that will force a retriangulation around those areas, and the triangles will refine themselves within those areas. So again, the key point to all of that is, use what you can see. All the data that you're going to use, and they all must be at the right elevations. There's another one that's even a little subtler than that. So you got a bunch of points, you can't really tell much about it, but maybe, some of those points contain things like fire hydrants, and the elevations were taken up at the top of the plug on the fire hydrant. Well, that's fine. That shows us where the fire hydrant goes. But unless somebody measures the height of that plug above the ground or gives us an elevation for it at the ground, it's going to throw a little peak in our terrain model, and it will be wrong. And you have two choices. You can either take it out of the triangulation, or you can adjust the elevation of that point. And that's really the only two choices you have there to do it. I have a surveying colleague that I've used on several of my design jobs. And I would go out there and have him get me, all of this point elevation and things that I need to create. Usually they're on like, drainage and storm management, stormwater designs where I'm putting in pipe networks and such. And, I said, well, give me the building corners, give me this, give me sidewalk edges. He's really good about that. But then he comes in and he gives me a bunch of points that include these building corners, but they're all over the map vertically. They're like up 4 feet, up 1.5 feet, up 8 feet. And finally, when I got that figured out, that, those elevations were wrong, and they're going to try to form triangles with the other points out in the parking lot. And, it looks like I've got a ski jump coming off the side of my building. And I was asking about it. He goes, oh yeah, well, that's because when I shoot my buildings, I don't actually go over there and occupy the point. I get all of those with my robotic total station, my reflectorless total station. So he can just shine the laser on the corner of the building and he'll get that point down, and it captures the elevation. But he didn't do anything to tell me that, hey, that elevation is so high up, or don't use that as an elevation point. So it caused a little bit of problem. So we have to, on the office side, that's how we have to do that evaluation. But there also is a bit of responsibility on the field crews side, that they need to understand what you're going through in the office to try to put these things together. And I know that's easier said than done. That's a bit of a challenge to make sure that somebody who really all he wants to do is go out there and start slinging points all day, and he doesn't really care about what you do within the office. And it's sort of difficulty. It's sometimes a difficult task to get a bit of an enthusiastic buy-in on that workflow, so to speak. So, but as long as we understand it and communicate, then that's the secret to that success. But even if you have it, there's ways of dealing with it. And so again, we're going to work on these triangles. And remember, what we talked about is that all these triangles are going to form by sitting on every point along a feature, or a point out in space, looking around itself in a full circle, and start to connect triangle edges to other points that it can see. And that leads to things like this right here. If you can see that all of my data with these smaller triangles, that's really where my data is. And you can see, you see that little black line right there? That's one of the break lines that you saw in that previous little snippet of those break lines and road edges. And you can see these yellow lines. Well, that was the road edge up on that other end of this data set. And you see how the triangles are all coming down to that, and none of those triangles are going across. Now it looks like this is a triangle that goes across. It's not. That's a triangle back to back against it. So these triangles formed up against these break lines correctly, but then, where did these come from? Well, these came from the fact that this right out here is the tail end of this little break line. Up here's the tail end of that break line, that break line, that break line. Those are the black ones. So every point that it hits, and it'll sit on this point out here on the far right, and it will start to look around itself 360 degrees. It sees this point here, check, draws a line. It sees this point here, check, draws a line. Sees this point, check, draws a line, etc., all the way around. But when it gets back around this way, it can also see this point. It can also see this point. Now, it could also see this point, this point, this point, this point, if these triangles had not formed already. They must have formed already, but nothing had formed, say, from here up to here, or to prevent this point from seeing this. So you get all of these, what are called edge triangles or slivers. And different software handles this in different manners, but they're pretty much the same approach. You'll have the option to give it a maximum triangle size for those edge triangles. So if it's, one of these little ones down here, that size limit might decide to keep it, but if you tell it a bigger number and say, don't use those, then it's going to disregard those and throw them out of the model. The other way is if you draw a boundary around all of those outermost edges, that will form, and that will act as a break line to keep anything on the inside of this from looking across that edge, which now is continuous all the way around itself. Well, that keeps anything on the inside from looking across that boundary and finding anything on this other edge of it, but also the things on the outside can't look up here. So it just basically contains only the things that are valid on the inside of that closed figure as a boundary. So you can either, give it a maximum triangle length for the outside edge to do the reduction out there, what's called the edge reduction, or you can use a pre-drawn boundary. And there's some pretty cool techniques on doing that you're going to learn here today as well. Most of which are just automatic and they happen, but I want you to see them so that you understand what's going on. Okay. So that is basically it. And that one I was talking about, that particular procedure, is here, this shrink wrap entities. So you can see the fact that you've got, well, anyway, there's the words, but you can appreciate the fact you've got all this data. And if any part of it cuts into the inside, you're going to get these long triangles across open space that you know nothing about. And if you leave those triangles in, you're saying, okay, well, I'm assuming the elevation here is halfway between here and here, but you don't know that. And so when you put that boundary around, you want to tighten it in around everything that is just that original data. And so if you think about, the way shippers put that plastic film around things and then they heat it so it shrinks it, it does a shrink wrap around all the data. That's essentially what you're doing. There's commands that'll do that for us. Okay. And we'll see when we get to it. And of course, like everything else in Carlson, when it does that, it doesn't create a terrain feature or a special extended entity or any of this special stuff that you have to have special tools for. It just creates a polyline, a closed polyline. So that the implication of that being is you can use that tool to generate that, that's fine. Or there's nothing wrong at all with just simply drawing a polyline. As long as it's a closed polyline, it can be used as a boundary. And so that's, again, part of that Carlson philosophy. So it doesn't matter. You can spend as much time as you'd like drawing. It can be, you know, quick and dirty, kind of slapdash hasty, or you can have it actually, you know, snap into every single point along those edges. All right, so we'll see all that. But once you do everything there and you model this terrain, you're going to evaluate again. There's that word again. So, you know, don't just say when it runs and gives you no errors that, oh, hey, it must be correct. You know, still look at it to see, because you can get a terrain model that is mathematically correct without errors, but it does not reflect the actual situation on the ground. Okay, so the best tool we have to do that are your eyes. So you're going to use your eyes and evaluate all of this data to see what creates these surfaces. Okay, so we're going to spend the major part of the day, I suppose, a little bit later in going through all of that kind of terrain modeling nuances. Okay, those are some of the things that, you know, a lot of people never really get into designing and thinking about the actual tweaks and you know, the richness of the tools that you have at your disposal. A lot of people are in the can say, hey, just hit the triangulate button, get a surface out, and then move on. And sometimes it causes issues. So we're going to we're going to sort of keep that in our hip pocket, and then we're going to play around with some of those things, looking how we set break lines. We'll see about, you know, we'll take a look at this data. We'll learn how to use that 3D viewer. We'll see about evaluating the surface. And again, that's real photometric data. Here's that drawn polyline as the shrink wrapped boundary. And then when we get to the end of it, here's an example of, you know, how the contours that we generate with part of that command can overlay the ones that were delivered in the drawing as drawn polylines. And we see, even though we got a couple little misfits like in here, for the most part, we got everything that matched. And we'll see, you know, how to deal with that, how to take care of these outside triangles. We even take a look at how to model the edges of curbs if they're not provided as individual break lines. And again, there's some of that color by elevation. But then at the end of the day, and here's some other surface evaluation tools like generating a profile across the data to see what it looks like, making sure it's correct. And then we're going to conclude by this exercise here called putting it all together. And we're going to basically start with a bunch of points, and we're going to end with a modeled stockpile of material, and we're going to design a borrow pit into that, model all those surfaces. And you can see, well, then we'll take that one away from the other. We got a resulting merged surface, and then we're going to see how to put a little haul road into our borrow pit and drape that on the surface, design a profile for it. You know, here's our road profile, this red line, and then use that to create a little road model where we take that three-dimensional center line, we offset the edges, and then we let it tie into the ground around the outside here so that we know where those sloped edges are going to hit the ground. And then we're going to merge that into that composite surface up there and have it generate, say, some grading contours, and they're stationing along the road. You see how it grades into there, and you can see the actual, you know, when we spin those contour lines up in 3D and we've got the materials behind it, you can see that road edge that comes across there, the fill surface on this side, comes down and hits the edge of that stockpile, and it comes in here, and it cuts through this bank of this excavation, because that's going to be our borrow area. That's actually the results of that borrow operation from that stockpile, so we can compute those volumes and such. Okay. And that's really where we're headed with this. But we're going to spend a little bit of time first in this really rather complex data, talking about modeling the terrain and understanding what we can do to our data to help condition it. We're going to look at algorithms to help us assess the data. Okay. And then how we can fine tune all of that that goes into building our existing ground surface. Okay. So now we won't spend a lot of time. I'm not getting into a real deep dive on the stuff, but I just want to show you some of the things that we're going to be doing. So let's start by opening this file that you've already had open a couple times yesterday, called Sample from T3 Global. And let me see here. Yeah, so it'll look like this. So I'm going to go over here and start my Carlson software. And when that comes up, you should see that file somewhere in your list of recent files from yesterday. Here it is in mine, Sample from T3 Global. If not, choose Open Files, navigate to your training data set location, and the drawing should load up. And it's going to look potentially sort of weird, but this is an actual drawing file that was produced by a photogrammetric firm of an area that it's actually near it's at where the Pennsylvania Turnpike intersects with Interstate 70. It's a little place called Breezewood. It's about halfway between Pittsburgh and Philadelphia, or maybe not quite halfway. But in any case, a pretty involved place with transportation world, but not right out here. This is just one of the commercial areas near there. The actual turnpike is like way over on this side here, and then this road here leads up to I-70. That becomes an on-ramp to I-70. So but it's good data. This was done for the Department of Transportation, but we have permission to use it to train with, etc. Now you can look at this and see immediately, there's a couple of things that come to mind once you're familiar with this, is that if I try to model this data into a surface, I'm going to see, because if all of my data followed this sort of a square, non-concave shape, I would be okay, but it doesn't. There are insets. So anywhere that the data cuts into its overall shape, it's called a concavity. Those are going to be areas where you can rest assured that triangles are going to form, long, skinny triangles across there that you're going to need to deal with in several fashions. And one of which can be to simply leave them alone and just ignore them. Is, you might be working over here and you don't care what's going on there, so you just don't bother to fix it. But it's easy enough to fix, and it's usually it's almost always the best practice to get in that habit. All right, so let's talk about some of the tools that we used yesterday as well, and see what they're going to help us to evaluate our data that we have here in front of us. So let's start on the file menu. And let's go down here to this drawing cleanup command. And if you remember that this is where you can do things like if you get, say, a set of architectural plans in from somebody, there's their architectural units, you can convert back into your units, and that will scale the drawing and all those different kinds of things. These are things to clean up a drawing that comes from somewhere else. That's really what it's meant to do. You can also do right here, BB, that particular checkbox says convert Civil 3D or Land Development Desktop AEC, which stands for Architectural Engineering Construction, contours and points into Carlson format. So if this were a Civil 3D file, and you know that going into it, it would see those contours, which, as you know from Civil 3D, those aren't individual drawn polylines. It's just essentially a picture, or it's the style of how you are looking at that surface. You select one of them and you select the entire surface because that's the object you're dealing with. So this checkbox on here, if this were a Civil 3D file, it's not, but if it were, it would recognize that surface object and it would dive into it and start to pull out those contours. You know, it would recognize the contours as a surface object, and then it would dive into that surface object and it would generate and save a terrain model file, or what we call a TIN, a .tin triangulated irregular network. It would save one of those in Carlson format automatically, so you don't have to do any conversion. A lot of people don't realize it'll do that. They'll go and they'll explode those objects and they'll build a surface from the contours. And again, that's the worst thing you can possibly do, is build a surface from the contours, because you lose all the data that's inherent in the surface model that originally created those contours. You lose those particularly corner triangle pieces. So, but again, get familiar with this command, this toolbox. But what we're going to do with it right now is we're going to hit the clear button, get everything off, and we're going to go to that set elevations outside range to 0, and it wants us to give it a particular set of numbers. Right now, and these numbers stay from the last time I ran the command. Well, I don't care what they are right now, but I need to know what my drawing contains. So if I turn that checkbox on to say I'm going to do it, and then if I hit the scan drawing button, it's going to read the drawing and tell me, hey, you range from 1279.666 up to 1347.090. I'm familiar with the job. I know it's up around the 1300 range in elevation. That looks good to me. But if I saw some really bogus numbers like 5 or 28,000 or minus 50,000 or something like that, or minus 13,627, I would know that I've got a problem. And then I would see those numbers, and let's say that was a bad negative number, then I might come in here and type in what, some number that I know is lower than what I need it to be. And then I would hit the OK button and let it handle taking all of those things at those outside extreme elevations, doesn't throw them away. It just simply sets their elevation to 0 so I can deal with them later. Okay. So if I scan the drawing, I look at that and I say, well, that looks fine to me. And I'm just going to hit cancel. There's nothing I really need to do. Now there's other things you can do. For instance, you could, let's uncheck that and let's remove duplicate line work, duplicate text and points, and let's say this join line work with the same endpoints. Sometimes you get a bunch of lines that have been exploded and they're just segment after segment after segment, so that'll help you there. These are all okay. Let's erase any text that is just blanks. A 0 length or fragmentary lines. Now, you may wonder, what is a 0 length line? Well, it's a point. You don't generally have them in AutoCAD files, but sometimes these files originate in other software. And MicroStation in years past did not have such a concept, didn't have an element known as a point. A point was still classified as a line, it just had 0 length. So that's what that would do. If you just wind up with some points, it would get rid of those. Now, in this case, it will not get rid of those little pink points that you have, little spot elevations, because it's not saying getting rid of points, it's getting rid of 0 length and fragmentary lines. So that part's okay. If you had a drawing that had thousands and thousands and thousands of contours in them, those contours were really tightly dense with vertices that were sort of unnecessary, you could tell it to reduce polyline vertices. And what that does is it evaluates every vertex along every drawn polyline, and it looks to see, if I get rid of that next vertex, am I going to affect the shape of this polyline adversely? And it would look at this offset cutoff value and say, if it will, if it's greater than that value there, being off of the same line from where I'm standing on this point, looking 2 points ahead, I look at the point in between, and if it is further away than that number, then I need to keep it. But if it's less than that, I'm going to say it's really not materially affecting the overall shape of that, and at the candidate to be thrown away to reduce my vertex counts on my polylines. So a lot of tools here, and every one of these tools that you're looking at, by the way, you can do by individual other tools in the software. This is just a place where it all comes together. So let's just leave those as they are, these 3 and then these 2. Use it, work on the entire drawing. We'll say okay, and let's see what happens. It said, there were no blank text, there was no 0 length and fragmentary. There were 2 duplicate lines that it got rid of and 27 duplicate points. All right, so we cleaned up a little bit of something there, and that was good. So that's their first step at looking at things. What else might you want to do? You might be curious as to, what are these white squiggly lines? You might select one and see that that's on a layer called VTopo BKLN, which is the National CAD standard version of saying V for survey, because the structural guys got the S's. So V-topo, it's a topographic feature and it's a break line. So it makes perfect sense with what it says that is. I look at one of these contour lines, I see it's on VTopo MINR or minor. I look at this one and it's major, MAJR. So somebody followed a layer naming tool or layer naming pattern to sort of follow that national standards. If I look at these other contours in these areas, here's one called VTopo minor OBS, VTopo major OBS, and that stands for obscured area. And you'll see like that word right there, obscured. They're saying, hey, there's a bunch of trees and brush. We're not sure about this, so we're not going to guarantee national map accuracy standards in there. So within that boundary, these are obscured, and they draw them in with separate contour layers so that they actually look different. So this is everything in our drawing. I'm going to also go up here to my layer control, make sure that every layer is turned on and thawed. Okay, it is. So there we have the first step in looking at a couple things. All the layers are on. We've identified a couple of things we might be interested in terms of seeing what layer it is, but let's use a more automatic tool than clicking it and looking at properties. If you go to inquiry and choose your drawing inspector on and off, tells you that it's on down in the status bar or in the command line area. Right click to activate the menu. So I'm going to right click that, and I'm going to display the layer name. So I just right click it and click left click the ones you want to see. So I'm going to have the layer name and the elevation. I'll go ahead and do that as well. And so now that's just in here in the midst, and all I have to do is just hover the mouse over it. So I see V-topo break line, there's changing elevation. So I know that that's three-dimensional data. I look at, say, that sign, it's on a layer called V road sign, but it has no data. It's not at elevation. I look at these contours. There's one that's V-topo minor, and it has a constant elevation. So those are all things that I expect to see. Here's a piece of this blue text. It's on V site outline, OTLN. I probably put on the wrong layer, who knows? There are some building outlines up here. There's V building outline, V storm manhole. There should be some curb lines in there. There's a bunch of things right in here. For instance, as a see it V road outline, but its elevation is 0, 0, 0. So that's the actual outline shape of the pavement. That's like the pavement edge. But it's not elevated. These lines over here, though, there's your V-topo break line. Those were the ones where they actually elevated the edges of the pavement. Okay. So that's a way of looking at the contents of your drawing. There's another, like a red building over there. Looks like it's on V-topo or V-site structure. That would be. I've got those points. I can find another one right in there. There's a point right here that I'm looking at, and it's any of these. See these points? There's purple points, and those are just CAD points, by the way. If I go down to my settings, my IntelliCAD settings, my point style, and if I choose use these X's, you see those are all a bunch of points. I'll put that back. And that's on a layer called V-topo DTMP, which stands for Digital Terrain Model Point. So all of those things sort of give us an idea of what's there. Now I'm going to right click the mouse and choose turn off the drawing inspector, because I don't need that block of words following me around all the time now that I'm through with it. But let's go back to inquiry and look at our layer inspector. Remember, this is one where you can sort of see what things are on which layers. And we'll just take a peek at a few of them. Here's the BLDG IDN. That's a building identification. I see it's got two items on it. Give it a minute there. So when I zoom in up here, and I'm just going to click there in the mouse and or click with the mouse and use the wheel. So there are identification labels on structures or buildings. This is V-topo major IDEN, or the identification of those major contours. So those are my contour labels. All right, so I'm taking a peek at all of these. Here's a layer called V-topo major, obscured, minor obscured, minor, all of them, major. And remember, you can control click to see them all together. And let's see, we did those, and we also wanted to add these. So that tells us, okay, we've got 1, 2, 3, 4, 5 different layers that make up the drawn contours in this map. Now remember, these drawn contours are what the photogrammetric company delivered. And they are at elevation, they're usable, but that in and of itself is not the surface. Those are just drawn polylines. The surface is a mathematical model, and we haven't created one yet. Now, they had one to be able to generate these contours. And the best solution in a situation like that is to make that part of the deliverable, is that they're getting a model. I say, well, give me the model as well as the drawing. And, and so I won't have all that work to have to do to try to reconstruct that model. Sometimes they don't, though. And in this particular case, they did not deliver the models because they used some different software, but they did deliver all of the data that they used to create the model. We'll talk about it in a minute. All right, so this is a way to spot through some of this stuff, and you can just sort of, step your way down through everything. Because that was the last one. Up here's my building outlines, ditch, edge of water, the light EXTR. I have no idea what that means. Poles or something. There's the power pole with the guy wires. There's the poles themselves. Look at them together. Outline of the parking. 19 things there. Now, again, some of that stuff's on. So there's a road curb. Some of that stuff is elevated. Some of it is not. There's a guardrail. Road ident. In other words, the road names, the road identifications. There's that road outline. And again, it's just a 2D set of lines. So what happens is when you see all that stuff, all of those 2D lines, there's a thing called its own road sign, sight fence and all that. But all of those two-dimensional road edges and parking lot edges, they're done flat at 2D for two reasons. One is so that it can, if they wanted to, they can draw them with a particular patterned line, because AutoCAD can't display 3D lines with line styles. You may or may not have run into that and encountered that. Other software can, but AutoCAD and therefore IntelliCAD cannot do that. So it has to be a 2D line to be able to see a pattern. And that doesn't matter the elevation of that. It can, contour lines can be dashed, but 3D polylines are always continuous. And what you do is generally you'll put all of those line features on a layer, use it to build your model, and then freeze the layer so that you don't see it. And that's what this particular project was. So there's my B-side structure, and I've got all those little manholes and such. I've got some drainage head walls that are somewhere, maybe it looks like one in there. All right, so, and we're not going to go through all of this, try to identify, but these are some of the tools that you would use to help you identify what your data looks like. Now that's good. We get a sense of how well it's sorted, how well it's on the right layers, and things are where they should be, and we sort of know where to expect them. But we still don't know anything at all about the data, whether it's good. Now we do know a little bit. We did that elevation scan. We said, well, that looks probably pretty good. So, one of the next steps that I would do, and actually maybe even one of the first steps, is I want to look at this stuff in my 3D view. I got several ways of doing that. If you're comfortable using 3D viewing in the standard CAD window, you can use this little view cube over here in the corner, and you can say right now it's in a top view. But if I want to look at it from from the southwest up in the air, I'm going to go over here to this little corner and click that, and it's going to rotate it to that position. I go up in the air, which means this gets pushed down. And you can see all of these things up here are with elevation, and these things down below are everything that's drawn at 2D. Now you can also, a shortcut to using that cube to pushing like that is if you just hold the shift key, and while you're holding it, press and hold the wheel on your mouse, and then you can push the mouse around. You don't roll the wheel, you just press it in like a button. And that's another quick way to verify whether you've got, something that's way up here or way down here. You can do it that way as well. Okay. And then you would come back and hit the top part of the cube, or you can type the word PLAN, hit enter one more time to tell it which coordinate system to use, and that sets you in plane view. Now, that's all well and good and fine. The elevations look great as far as we can tell. But I want you to get familiar with using Carlson's 3D viewer because of all the additional functionality that it gives you. It's a little bit, you have to select something to put into the viewer, but it lets you view in that environment. And then when you exit, you come back to the drawing the way you left it. You don't have to reset the views there. And that's going to be, we're going to start to use these things on this surface toolbar, and it's this command that looks like a three-sided cube, yellow, red, and blue. And later on, you're going to see there's a command with the, yeah, Mike, I see you there. So it looks like a little stockpile. We're going to use those two pretty successfully. So Mike, yes, you had a question.
Yeah, just backing up a little bit. How do I get into the 3D viewer?
That's where we're headed right now. That's what we're talking about.
Okay, good. All right, buddy.
So now the one that we were just showing, that I was just showing you, that's not in the viewer. That's just in the CAD system. I haven't left the CAD system at all. Okay. And I did that by clicking on this little icon over here on the corner, or just press the shift button on the keyboard, keep it held in, press the mouse wheel like it's a button, press it and hold it in, and then push the mouse around while you're still holding those things in. And that lets you spin it around different ways. Now, if you get it stuck, you don't know how to get back where you were, you just type the word PLAN at the command line, hit enter, and then hit enter one more time to tell it which coordinate system that you want to use. Okay. So, and that's a way, I'll do that maybe first thing is I'll spin it up and take a look. But Carlson's viewer offers a tremendous wealth of things to help us with, and we're going to learn some of the basics. We're going to use it, from here on out today to help us evaluate what we're doing work-wise. So let's jump into that. Now it's available on the, which menu? I bet you could guess. The view menu, right? Because it is a view, and it is a 3D view, and you have two different types, well, actually three, but you've got two main types of viewers. You've got a drawing viewer and you've got a surface file viewer. And it's really the same viewer, but they're subtly different in the way they work. The drawing viewer is going to ask you to select things in the drawing, and you're going to be viewing elements. The surface file viewer is going to ask you to pick a surface file, one of those 10 files, and then you're going to be essentially looking at just triangles, whether they're shaded in or not. But all the controls are the same for the most part. The surface file viewer has some of the surface editing tools in it, which you could also do outside of the viewer. Things like swapping 10 edges, removing points, adding break lines, such as that. But both of these viewers, the drawing viewers, when it asks you to pick things in the drawing and go in the viewer, you have the option to add one or more surfaces to it so you can see them superimposed over each other. The surface file viewer, on the other hand, when it asks you to start with a surface file, also has the option to allow you to go back out to the drawing and pick things that you want to see and superimpose them on your surface triangles. The surface file viewer, if you start with that, also has one further difference, and sometimes you want to see it, is that it will generate and display contours of any given interval on that first surface that you start in with, and you can add multiple surfaces to it, but it always shows it for the first surface. It will generate and draw the contours for you on the fly. And you can change the interval to be anything you want. And it's just like you run the command triangulate and contour, but you don't have to go and dump those into the drawing at that stage. I usually don't do that until it's time to produce my final drawings. And that's when I'll put them on the proper layers and get them all going. But I will use this viewer to verify. All right, so with that in mind, let's look at the drawing viewer. And again, look at those icons, that colored cube and that little blue pile, it's like think of it as a little stockpile. It's on my surface menu. Now the big blue stockpile on the left of that menu is the command to actually build the surface. I don't want that one. I'm just right now looking at these two here. And there are a couple of other little evaluation tools in there. There's a surface inspector. There's a surface flyover tool where you can have it, sort of walk the surface. It's nifty. It's not anything that I use a whole lot of, but it's kind of neat. So let's choose that 3D viewer window. It's going to ask me on the command line to select the entities for the view. I'm just going to type ALL and I'll hit enter. And hit enter to finish my selection. And up it comes into the viewer. I'm going to just double click the top strip so it maximizes. And let's see some of the tools that we have in here. It tells me to click and drag the left mouse button to control the view. Well, go ahead and do that. Just click and drag, and you can see you can roll it up and back and forth. Okay. But now there's some differences in how this works, and you can get things all, upside down 6 ways from Sunday, and you don't know where you are and what you're looking at. Well, that's the case over here on the left, or up to the other left, over here on the right, there are some buttons, one of which is reset the view to plan view. So if I click that, it puts me back in plan view, and then I could do a zoom extents if I wanted to, doesn't matter. The wheel on the mouse works zooming in and out. It works to pan, where you press the button in and hold it and move the mouse. Okay. And some of these others we'll talk about when we get to them as well. But if your cursor, maybe your cursor looks like this arrow, or maybe it looks like this hand, you want it to look like an X and a Y with a double-headed arrows. And that you get that by this second icon on the top row of the horizontal icons over here on the right. And that is to indicate it looks like the cube with a little rotation arrow around it. So that's the tool that you use to orient your viewpoint, to spin your viewpoint around. Now you do have a few custom views. You say from the northeast, and these you can create and save yourself. But keep in mind that when you save a view called northeast, or the back elevation, whatever you want to call it, that doesn't just stick with this file. That saves it for everybody, for everywhere, no matter which things you've loaded into your viewer. So they may not make sense. You may want to, at some point, have to get rid of those. So anyway, let's go back to the easy way to understand this. And like it says, the little pop-up, click and drag the left button to control the view. you can do that and try it and see. But if you look over here on the right-hand panel, there are these three X, Y, and Z slider buttons, and it says rotation axis, and the middle one is locked. Okay. There's a reason for that, and that's to help us sort of keep ourselves oriented. Now you can unlock it. In fact, go ahead and do that. Unlock it. And now when you slide the mouse around, notice you can rock it left to right, as well as front to back, top to bottom. Okay. So, but if you, and I'm going to go ahead and put it back into plan view first, and then I'm going to lock it again. And now I'm going to move, press and hold and move the mouse around. And if I move it, no matter how much I move it left and right, it's locked. That Y-axis is locked. So I can only move it. And you see when you push it, you see the slider that's moving. That's my X-axis that's doing the rotation, whereas my Y-axis I can't move. Now I can spin it. Notice it's the Z-axis that's spinning around now, not the Y. But what happens to that and how do you get there? Look at the cursor. When your cursor is over what basically is the bulk of the data in plan view, the cursor looks like an X and a Y. If you get outside the edges of that, it switches to, and it's not exact, by the way, but it switches to a Z cursor. So that means when you click and drag the mouse, you're controlling the spin around the Z axis. When you're in the horizontal XY part, you're controlling the spin around the X and or Y axis. Now it can be with Y locked, or it can be with X locked, so that now the only way it goes is left and right, but I can't move it up and down this way. That's available, but I'm going to show you the advantage to keeping that Y locked, and this will help you understand how to position yourself in any spot and look at any part of your data. You're never guessing. Okay. And here's how to do that. If you start off in plan view, so if you need to go over and hit this green button that says reset to plan view, and then hit the button to its right that says zoom extents. Okay. Now, if you picture yourself standing in your driveway, looking at your garage door, and your garage door is one of those non-articulated doors. It's not got the hinged panels, but it's all just one solid door. And when it goes up into the open position, it just sort of picks the whole unit up and rolls it back into the overhead part of that garage door opener. So now, if you think about that and think about walking up to that garage door and reaching down here where the door handle might be, and you're going to take your mouse and click and hold the button, and you're going to push the garage door up, and you're just rolling it back up into the roof, or into the overhead space of your garage. Okay. And you might have to go back and get another chunk of it. That's fine. But roll it back till you get to be a fairly oblique position, about like this. You don't want to, go overboard, go upside down. You want it to be something like that. Let's say close to 80 degrees laid back. Okay. Now, once you get that position, let the mouse up and then move the mouse to the bottom to where it changes into the Z cursor, and you can spin it around that way. So get yourself lined up to where, let's say if I wanted to look at this little pond that's right there, I would spin this around, get oriented, and then point at it and let the mouse up, then point at it with the mouse, and then use the wheel to zoom in and out. Okay. So let's say I wanted to look down that road up there from that upper T intersection. Well, the easiest way to do that, and no matter what you're looking at here, is I'm going to be right where it is here. I'm just going to roll the wheel out to where I'm looking at most of the data, and I'm going to position that back up to be at that, 80-degree layback. And I'm going to come down here and spin it around, get lined up where I need to be, and then I can go back and zoom in. Now, these things are all, you can tweak that position and fine tune that at any point, but that's your basic motion. If you'll just pretend you're sitting in front of your garage door, lay it back, then spin it around to get lined up with it and say, I'm going to line back up down that pond area, and then point at it and just roll in. Okay. And if you need to, let's say if I wanted to look down the pond from this corner and I'm trying to do that roll in, I can't do it at that level. Just roll back out enough to where you can get positioned. And again, remember, zoom and pan works with the mouse. So I'm going to get positioned there. I'm going to look right down this bank edge into that stuff that goes over toward that pond. And I say, well, that doesn't really go into that pond. It does, but from a different route. It comes in off the back of that building. And then the pond also, drains out and goes down to the river at some point. Actually, this river comes in and fills up this pond. I don't know. There must be an outlet here that goes underneath everything. I don't know how to, but anyway, that's how you would use that to evaluate. Let's say I want to look down that, this road here, or, right by that park, these curbs, and those curbs, you see, they don't have the top line of the curb. Well, that's because that really is an asphalt wedge curb. I look over here in this little roadside ditch, and you see they've given me the top edge as a brake line, this bottom edge, and I see these. If I spin this around, I wanted to take a closer look at that little structure, and I see, oh, that must be the head wall for that ditch. I can see down there. Okay, so there's a ditch running here. That's maybe there's a head wall. There's a culvert that comes under this little driveway entrance. Okay, so it's a great way to get to know your data and to help evaluate anything that you've done. And again, if you need to reset things, put them back in plan view, but this lets you look at the results of some of your work. Okay. If you look, and we'll look here in several other trips when we come back into this, there's a settings tab where you got a bunch of controls here. There is a model tab where you've got some controls. And so let's say I've noticed I'm going to switch, and instead of using that control icon, I'm going to switch to the arrow, the pointer. And so what happens is if I hover the mouse, so you see down the status line below here, it's going to read out what that is. If I'm over a contour line, it says that's a lightweight polyline or a 2D polyline. It's on a layer called VTopo MINR and has that elevation and that length. If I hover along this white brake line, you can see that if I can keep it still there, the elevation range is reported. It's sort of like the drawing inspector. And if you double click anything with the arrow, it lets you change the layer. You can turn it into a 0 elevation. You can say add to selection, so that when you exit this, you go back into the CAD system and it is part of a selection set that you can use to run the next command. You would enter previous because it had been added to that selection set. Okay. But let's say if I'm looking at this and I see that's on a layer called VTopo brake line, and I really don't want to see that, and I've got all these little points that are on. I can't quite get it to see the point, but I happen to know what that layer is. But you can then go to the model tab, and the model consists of points, polylines, surfaces, text, 3D faces, blocks, and solids. And you're looking at data that is, from the drawing with all of these layers in it. They're all right now turned on. I'm going to say, let's turn off my V-topo break lines. So now they're out of the way. So I don't have to exit the viewer, turn the layer off or freeze it, and then go back to the viewer. I can do it right from here if I know what the layer is. There's my DTMP for points. That turns all those pink points off. And let's say those obscured triangles, maybe I want them to be a different color. So if I point to that layer, and all I did to turn those on and off was to double click it. So if I select that layer, right click and choose edit the layer properties, I can, there's my show hide, what I did before, but I can say maybe turn that into a different color for those. Those are the minor obscured, the major obscured. You can do the same thing, make them a little darker orange. So, anything that helps you do that. Now, so you see I've got a nice visual contrast here, but if I were to go back out now, which I will, to my drawing, see, I didn't change those. It's just in that viewer allows me to modify things to make it clearer as to what I'm looking at. Okay. So that brings us to break time. And again, we'll get you full 15. So we're going to come back at say 10 minutes till the hour. But any questions so far on this? Yeah, I know we've been looking at getting ready to do stuff. So we're going to be doing stuff next. Okay. So yeah, Mike's good. All right.
I'm good.
All right, BB, sounds fantastic. We'll see you back here at 10 till.
See you then.
All righty. Turning the recording back on. My sincere apologies for that gap, because that was actually some of the better portions. That would have been nice to have. So I'll make sure you get a link to one of the other classes as well, so that you can see some of the other things. In fact, I may I'll pick more than one other thing. I'll give you some other videos you can look at and see. So just keep in mind, every class is obviously somewhat different. So, but you'll still see all of those processes repeated, plus they're outlined for you in the book. So now we were talking about, putting those exterior boundaries on and how you can get rid of those outside corners by several methods, one of which was that you just draw a polyline, and the other is that you could use that interior and exterior maximum triangle size to trim that down as well. But in order to draw that boundary around your data set, there's a couple of ways of doing that as well. You can just draw the polyline, or you can do what's called shrink wrap entities. And that's what this command was originally designed for. And I want to show it to you as a separate command because there's other uses for it as well. I'll show you that in a second. So if you draw on the draw menu, and you come down here and you find this little package called command called shrink wrap entities. Now, don't confuse it with the command that's right above it called boundary polyline. That's a standard CAD command, and that works a little bit differently. The problem I have with it is that the name of that command sounds like that's what you want to do. You want to put a boundary around stuff, but that's a different thing. So I'll show you what that does in a minute as well. But shrink wrap entities is what we're going to be doing. If we choose that command, it's going to come up here and give you several choices, and one of which is to go across gaps, which is what we'll use for this kind of data, which means it's going to sit on the end of one of those things and it can look across and shoot that gap of empty space to go on to the next spot. The other one is to choose bounded line work only, and I'll show you that in just a minute. We look at some variations. You can give it a layer name. I'm gonna put it back on my clipping boundary. Doesn't matter whatever you want to call it. And then you can give it a maximum gap that you want to allow. This is a new parameter. They used to not have that. That's interesting. That will help keep the jig jag stuff from happening, I believe. We'll take a look at what happens. But here's the way you control this. Now, this is sort of hard to wrap your head around as to what it's asking you for, but here's the here's the process of what's going on. The choices are none, low, medium, and high, and that is a method to bring about this thing called perimeter reduction. You see right there the label of it. And go ahead and choose none, and we'll talk about what those mean here in just a second. So if we say none, we can turn on to ignore zeros if you want, that's fine. And we'll leave it as a 2D polyline instead of a 3D polyline. Doesn't matter in the instance of using that for a surface boundary, either would work. But 2D will keep it simplified and it won't get necessarily picked up in the modeling and the triangulation process itself, other than to be a boundary. So let's leave it sitting on that and say, okay. And now I want you to select the points in line work to shrink wrap, just select everything. Okay, so that's what that gap did with that new parameter. All right, so let's select that and uncheck it and run the command again. It's on the draw menu, shrink wrap polylines, or just right click, choose recent commands, SWP lines. And let's change this gap up now to 200. Let's see what that does. Yeah, that was more what I was looking for. And now this is interesting. This is actually, I think, a bit of an improvement in the command with being able to put in that gap. Remember when we looked at our triangulate and contour command, this command, and we put in these numbers here for the maximum triangle edge? Well, that's how that's behaving here before. It used to not do that, and I used to generate something like this. I'm going to do this again, and I'm going to run that gap way up and show you this is what it used to do. Let's make that, 2,500. I'll say, okay, I'll grab this and that. Oh gosh, even that. Say 5,000 maybe. Oh, wait a minute, here it is. This got put back to low instead of none. So if I say none, and I say, okay. Yeah, that's what I was looking for. So here's what none means. And I'm going to change this. I'll put it there, and I'm going to put it on this different layer here. I'm just going to, so it doesn't get erased in a minute. So I'm going to put that on the topo break line, and its line weight. All right, so there's the first one that we just did, and you see what it does is it draws an outline around the perimeter of what would be the triangles if it had made that surface. Okay, remember those long skinny triangles that were over here and that were down here in this corner? That's what this does with none set as our value. If you run the command again and say none, instead of saying none, if you said high, and you said, okay, and we're going to select everything, but I'm going to shift select that yellow line because I don't want to include that. And now you see how that goes in, and it goes in real tight and it jumps in and out and then out. So it has reduced the things on the outside edges of it really a high amount. So what's going on behind the scenes is when you run the command and you tell it, let me just show you the command again, and you show it this value, and it's called a perimeter reduction. Now, what you're actually showing is, let me see if it tells us here. Yeah, it used to report it. It doesn't report it anymore. But what's actually happening behind the scenes is it's actually doing the triangulation of that data, just as if you said triangulate and contour and make a surface. It's doing all that in memory, and it's doing it very quickly. And it's looking at those outside perimeter edge triangles. That's why it says perimeter reduction, perimeter edge reduction on that stuff. So when you say high, you're saying I want to reduce those outside triangles along the perimeter to a high degree. If you say none, then you see it allows it to shoot across the entire gap. Well, now with the extra little now with this extra little maximum gap number, if let's put it down to something like 200. And I think it will erase this other one, but we'll just take these out anyway. $200, and then let me put that back to none. I'm sorry, I keep forgetting to do that. So that, and then we'll take those guys out now. So you see the difference here, and this one, I'll show you that intermediate step. All right, so I had the yellow one with none. The blue one, the cyan one, was with a high reduction. And this one, even though I said none, so it should have followed the yellow, but I gave it a maximum gap of 200 feet. So it couldn't look here and find this piece up here because that was greater than that maximum gap. So that's a new parameter in that command. Same thing happened up here. That was the original, but that distance across was greater then. So this only got to go up to here. It couldn't go up to there because that would have formed it too long. That is exactly the same thing as this number in here when you set that exterior triangle length. So that's really what's going on. Okay, now I'm going to select those and just erase them all, and missed that one. I did it twice, I guess. All right, so that's if you draw the command manually, and then you can use it when you go to triangulate and contour and it asks you to pick an inclusion perimeter. You would pick that boundary. So, but the other thing that they've added to the triangulate and contour command, if I choose that triangulate and contour command again, and I'll leave the file name the same, use inclusion and exclusionaries, yes. Or if I say no, in other words, I'm going to be asked to pick an inclusion or an exclusion area, but if I haven't drawn it yet, it lets me do it inside this command. And right there's those same things that you got from the shrink wrap polylines command. So the shrink wrap perimeter reduction, none, low, medium, or high. And if I just, low or medium tends to work really well. You don't get all the really sharp jigger jagger in and out, in and out, in and out that high gives you. But if I say put it on maybe low to keep it not quite so choppy, and then you've got a setup button. And when you choose that, you can do the 2D or 3D. You set your boundary, just like we've had before. And if you don't check this, you won't see it. So I always like to at least see what it comes up with. So in case I need to do any modifications, I'm going to exit the errors. So I look at that and I say, well, that's pretty good, except I don't want my contours to sort of end here. So I might just highlight that and hover over a couple of vertices here and say remove vertex and sort of straighten some of the kinks out. You know, you might go up here and do the same type of things. And let's suppose here's another common editing tool. See how this right here, and it found those. Let's go back here to my point style so you can see those points. So you see the points there now. So what it did was it found those little points along here and it sort of drew that shrink wrap boundary. But if you wanted to say, take this gap out and just go from this point to this point here, well, obviously you can do several things. You can select it, hover, and reduce vertices. That's one way of doing it. Sometimes there's more there than you want to do, like there might be just hundreds of them all jammed together and you want to try to just straighten it out. So there's a variation on that command on the edit menu, polyline utilities. Remove polyline, and that doesn't mean erase the polyline. That means the commands to the right of that are removal commands. So if I remove a polyline vertex, the advantage of this, as opposed to hovering and right clicking, is that you just select it. Now these little temporary blips are going to pop up, so I can just click, and it doesn't matter, you know, what order I pick it in, and it just, you know, I just click near it and it takes that nearest one and takes it out, so it straightens it out. So that's one way of doing that as well. But let me show you another technique of doing something. If I go from there, and let's just make this yellow so you can see it differently. And maybe I'm going to put these back on. Maybe I'm drawing a polyline. I'm going to say there. You know, maybe I span across. Now, a couple of things you can do is you could use that to trim this portion out and then join this to this to this. But there is another sort of variation on that, and I don't know if it is on the edit menu here. Let me take a quick peek. No, well, there's another nice command, make arcs tangential. So that makes, you know, makes the arcs, so if you're doing a road alignment, everything's correct. You don't have a kink in your alignment. That's a new command. But the one I'm thinking about is this. I think I can just erase that. Let me set here, and whoops, sorry, I'm going to just get on that layer, set my current color and my current line weight. It's a bit of a trick, and I'm not sure it'll respond to this because it wasn't generated as a contour, but we'll take a quick check and see. There's under the surface menu, you've got some contour utilities, and this is where you can edit the contours. Okay, now what happens to this is if I select that, I'm going to say no, don't change. So you see where I've picked a point and it went right to that point, and it says now, pick an intermediate point or a point to end. So if I go over to here and pick that point and then hit enter to end. So now click a connection point to there. Okay, let me see. All right, so if I select this contour, there we go. So pick an intermediate point. So I'm going to pick that endpoint, and I'll pick this endpoint and enter to end. Now pick the reconnection point. There we go. So I picked it as to where it's going to go in. So you could say, take that and you just trick it into saying, hey, that's a contour. And so if I repeat that command, I select that as my contour line. I'm not going to update my surface. It thinks I'm changing it. And so now, you can add any kind of stuff that you might want and put it down there. And then it says, oops, sorry. So I can pick this, no, and it's just anywhere I want it to be. So if I go from here to here to here, hit enter to finish. Now, where do I want to reconnect? I'll reconnect, right there where it comes out, or maybe even up here. So what it does is it takes what was originally there and then joins into that thing and then rehooks it back together. So the effect is like this. It would be as if I drew this line as a separate polyline. I drew the other line, I trimmed off the parts in between it, either by breaking the original at those connection points, or if I use that as a trim edge, got rid of the parts on the other side. And then I said join nearest, and I pick, and joined those things together. So there's a number of different ways that you can do this. I find on things like this, however, when there's not, see right here's a case where there's really too many to sit there and sort of pick my way around the vertices. So that would be a case where I might well either just draw a separate polyline. I'll go from, say, that endpoint up here to this endpoint. And then I might use that to break this red line with, make sure I'm on that actual endpoint. So if I did that and said, let's trim, and if I trim that part and then this part, now it leaves over these little leftover pieces, which I can ignore or erase separately. Now I've got this polyline, this polyline, this polyline, although that is still goes all the way around. So I'm going to run another command now called edit join nearest, which is also on the polyline toolbar. And it has some options to handle things. In case they don't exactly join, I can pick an allowable gap. They happen to join. I can do some filtering here. I would say, okay, now I want to pick the one that I wanted to end up as to be my last pick so that it inherits its properties. So I'm going to pick this yellow one first and then the red one. I hit enter, and now when you select that, it's one. If you look in the properties down at the bottom over here, it is closed. It's a closed polyline. I might do the same thing across there instead of instead of having to go click, click, click and remove all those vertices. Any of those particular methods that you want, I could remove vertices here, and I'll just see, I'm not snapping to any of those points. I'm just blindly clicking until it reshapes itself. Do the same thing with it here. You know, so any of these ways that you want to get rid of things or reshape anything that you've drawn, it doesn't matter. And you saw how I ran the command earlier under the surface menu, contour utilities that said edit contours, because in the end of the day, those contours that it creates are just drawn polylines. And so it's just an editing function of the polyline. It's just a different approach to doing that. Okay. So that's how, you know, several ways you can do the shrink wrap. You can have it generate as part of the triangulate and contour surface command itself. Then you can go through and reshape some things so that they're not quite so glaring, you know, a transition, not so, you know, quick a clip. Don't have to do that. That's purely aesthetic. And you just might want to do it just for the way it makes it look. All right. So that's entirely up to you. It's all fine. Any of those ways that you want to do it. Okay. Now, let's talk about some of the other uses for that draw shrink wrap boundary. And they are like this. Now that, you know, we create that as, and we're going to use that as an inclusion boundary. And please don't forget this, by the way. When you go to triangulate and contour, let's run that command again. If you've got that surface out there, surface, or if you got this boundary, triangulate and contour. If you or if you check to use the inclusion exclusion areas, that means it's not going to draw it for you internally, but you're going to go ahead and just use it. Okay. Now, when you do that, and even if these numbers are up to where they don't get taken out of the mix, the boundary will do the trimming. But when you do that and you go to hit OK, just remember that you've turned this on, you say OK, and now look at the prompts down below here, and it's going to be missing that first prompt. That's again the error. Actually, if I just because that was created the last time I ran the triangulate command, that's why it erased it. So I'll put that back. But when you run that command, let me change this, erase previous contour entities, and it means not just contours, but anything the surface creates, labels, the whole bit. I'm going to turn that off. So now I'll say okay. So now when it prompts you, it just says select. Oh, look at that. Now it's back. Select inclusion perimeter. Is that the switch? If I say all current entities, yeah, that's when it goes away. Very interesting. Well, let's see if I just have something that wasn't created with that before, and if I run that command, and we've got it, I'm doing a thought process here. And if I say, okay, no, that apparently, and it's still a bug. All right, so here's how to get around the bug. When you triangulate and contour, if you say erase previous contour entities, if it's sitting on all, let me see if it's also on that one. Yeah, it is. All right, so once more. So if that erase, previous contour entities is anything other than off, then you won't see that prompt. Now, that's a bug. I'll get that straightened out with their programmers. What you normally see is this prompt right here. It still says select entities. That's after it's been handed off to the CAD engine, but it should say select interior perimeter polylines, and it can be more than one, or enter for none. So at that point, you select that boundary, okay? And you can select more than one. When you're through selecting, you hit enter to finish, and now it says select exclusion perimeter polylines or enter for none. So I don't have any. Again, I could have put the building outlines on there. So they go, and now, and you notice the bottom line prompt always still says select entities, but read the line above it as to what it's looking for. So now it wants to know the data that you want to use, and that's where you can bring that in and resolve that based on that particular boundary. Okay, so that's a very interesting little gotcha that they need to turn the switch back on. One real quick pass on this, and we'll jump into our little workflow exercise. I'm going to repeat that command again, and here's something to be aware of. If you do draw the contours, okay, and I'm going to put these on a layer, and I'm going to put them on separate layers than what they had before. So I'm going to say CTR-INTER for the intermediates. I will check on to draw index contours, and I will say CTR-INDEX. Okay, so those are the layers. They're going to create the layers. We can change the colors, look at them later. Now, the contour interval, usually when you change this, notice that this number down here will change with it, because it knows index and intermediate are every fifth contour. So 2s and 10s, 5s and 25s. The only one that doesn't work correctly, or it didn't, is it did. Yeah, so if you put in 10 here, it doesn't change that to 2. But if you put in 25, oh, it still doesn't. So apparently you have to put it up here first. Maybe this works the way it should. So a 1 foot interval, a 5 foot index. So you could change that to maybe go to every 10th foot with 9 intermediates in between. I guess that's how it would work. All right. Now, what else can you do on this? You can also, this is contour by interval. That's what we mostly do, but you could contour a specific elevation. You might have an elevation here that is, well, let's put this here and call it, let's say we're going to look at 1325.37, okay, as an elevation. And, you know, we're going to say we're going to label the contour labels as well. And this would be CTR-LBL 108. Let's say, okay. Now, what's going to happen is this. I'm going to select my inclusion, no exclusions, set all my data, and we're going to exit that. And now, what did we have generate? It went through that surface and it found everywhere along that surface that had an elevation of 1325.37, and it drew that polyline. So, you know, maybe that's a floodplain elevation. Maybe for whatever reason you need a, you know, to show where that elevation happens to be, if it's less than that or whatever. So you can do more than just one. You know, it doesn't have to be one of those nominal things. Now, here's what happens if you, and if you look at these, you know, again, that has an elevation over here of 1325.37. If we leave that in there, if we say, well, I don't like that, I want to go back to fix it, I'm going to triangulate and contour. Now, if this on the triangulate tab, if it says erase preview contours, and if that's off, like it has been, and I say, okay, I'll say, okay, I pick my inclusion, no exclusion, I grab my data, and it's going to warn me about some other errors as well, where I've got some, where those crossed, I'll exit that. But now look what's happened is that these have become part of that initial data. So you could get, let's say if you've you modeled something, you found some problems, you fixed some other problems, and so that the contours were going to be different, it's going to still look at these contours that you did in the last pass. So you need to make sure when you're doing that, if that is turned off, that you want to go back to edit, erase by layer, and clean the decks. So I'm going to clear that, select from screen, I'm going to select that label. I'm going to select that contour line there. I'll select this label in case it's on a different layer. I don't think it is. I think it was fine. And say, okay. So now that is taken out of contention. Otherwise, when you do this, and if you have this erase previous set to all contour entities, then when it creates it, if it created contours before and boundaries and labels, it will erase those before it lets you pick them to be considered, okay? Now, here's the problem with that and why you should be aware of it. Let's say you've built your existing surface and you've generated existing contours and you've shown them in the drawing, okay? Now, you're working on a pond or a parking lot or a small design part, and you're generating surfaces for that, and you're trying to build a surface based on those designs, and you want to plot those contours. Well, that's all well and good, but when you go to build that other surface, that different surface, the design surface, if this is set to erase these all contour entities, it's going to go back and erase those ones that you're now happy with and you want to leave alone. So be aware that that's the point at which you should be setting that to off so that they stay there. But also do not panic because of this. I'm going to leave it off for right now. I'll show you how we can work on that. So if I say, okay, I get that, no exclusions, get all my data. I'll ignore those. I got to fix this one more time. Sorry. I'm going to erase that weird contour. I forgot to change that. So if I triangulate and contour that, once again, I'll go to my contour tab, and this time I'm going to contour by interval. And instead of that one, I'm going to go by ones and fives. All right. No smoothing, no reductions, any of that. I'll just say, go ahead. Yes, select, finish selection, grab my data. And off I go. And there we are. It's like my exit of my errors. And so now I've drawn some contours. All right, once again, let's fix the labeling. I'll go to my labels and I'm going to label index contours only. And I'll just say one label per contour is fine. And I'll say, okay, select, finish, no selection. So hit enter, select everything, hit enter. Off it's going to go, it's going to draw my contours, and here they are. Now I've got drawn contours. I'm going to change those layer colors for just a minute. So I have CTR indexes. I'll leave, I'll make those magenta, and the intermediates, I'm going to make a sort of a lighter pink. And so there's now what that looks like. And if I turn on all my other layers, I can take a look at how my contours coincide with the contours they delivered me. And you look at they're lying right on top of it, except for a couple of little places, like right in here and right in here. And the reason being that is that, you know, they used a different piece of software. There's a thing right here where it doesn't quite grab that. And you can fix that with your surface. You can, first of all, the drawn contours, you can just take the little vertices out, but that's not fixing the surface. So you could figure out what's causing this to happen and they didn't. Okay, so that's one means of some comparison. You can see how here these obscured areas are slightly off in different areas as well. So it's just a nice way to compare. If we have drawn contours and we notice that we built the surface from the break lines and the points like they did, and we should expect, and we therefore see a pretty good match of what they delivered. So I would live with that pretty comfortably. All right. So if I edit by erase by layer, all that's still there, I can just clean them out. All right, so they're gone. Now, if you happen to run those commands, I'm going to now freeze these little break lines and points. So if you should have happened to have said, you run the command and it said, erase previous contour entities, and it got rid of all of your contours, just like I did there with the erase by layer command, that's okay. You can always put those back. And here, and you don't have to re-contour the surface. Once that surface is built and done, you can go to the surface menu and you can say contour from tin file, because that tin file holds the surface information. It doesn't go away. So if I choose that EG3 and say open, it does the, remember the triangulate, contour, labels, and selection? So it's basically the same controls that you saw before in triangulate and contour. Just we don't have the selection filter, but we can still do things like use an inclusion area if we only want to see it in certain areas. Go back to contouring, change the layers, change different stuff. This is how, if you've got a different surface and you want to put like future grade contours, you know, grading contours on one set of layers existing on another, you would do it right here. Okay. So I would say okay to that. I would set my inclusion, no exclusions. And there it runs. Now you notice it put contours out here where they didn't have any because of my boundary out there, and I selected it and said just go out to that boundary. So it will either stop it at the edge of the surface or it will stop at the edge of this if it's inside the limits of the surface. So that's how that part works. Okay. So if you happen to have contours and you think you lose them, you don't have to build that surface again if you have saved that file. As long as you've saved the file, you're good to go on recreating those contours. Same is true of alignments, labels, all kinds of things. Now, here's another little trick. If I offset this, I'm going to offset this, say about this amount. And I'm going to pick this and go to the inside. Now I'm going to use that instead of this. So that's going to sort of scooch in a little bit. All right. Now, even though my surface exists all the way out to there, and you can see that by surface menu, draw surface, and let's just draw the surface boundary. And we'll use the same one we've been working with. So there's the actual edge of the surface. Okay. But now if I go to surface, contour from tin file, There it is. Use inclusion and exclusion. And again, make sure this is set to off so you don't erase those things. I'm going to then select, there's my inclusion. I'll finish that. Now any exclusions. Now here's the point. I'm going to go over here and grab these building outlines. Because there weren't any down there to begin with, I don't think. Maybe, we'll see. No, that's a parking lot, so that shouldn't stay there. So I'll say okay to that. Off it goes, and now I'm going to turn off their layers, just so they're not doubled up on us. So major ident, minor, minor. Okay, there we go. Just freeze all those for a minute. And so there's now my contour map. The text is pretty blanky, tall. Fix that. I'm going to go to settings, my drawing setup. Instead of 100 scale, I'm going to make that 30 scale. I'm going to just repeat that command. Surface contour from tin file, this time because I don't want to pick the layers. I'm going to say, yeah, go ahead and erase these other entities. I'll say okay to that. I need to keep that. All right, so erase by layer again. Let's clean that off. Now I will contour from tin file. Get my surface. Leave everything like it was. Why is it? Yeah. Apologies, we'll get it here. It's a contour from tin file. There's my surface. I'm going to turn that back off so it doesn't get rid of my boundary. I'll get my boundary. I'll get these. I missed, apparently hit enter too quickly. But it would have chopped those out of there. Even though the surface existed there, when I draw the contours back, I just clip the contours out. And, you know, so that's that inclusion, exclusion kind of behavior that happens. Okay. So the surface itself is defined. Let me demonstrate that one more quick time and then get it right this time. So 3, and I will use inclusions. Yeah, I'll say okay. There's the inclusion. Now, there we go. This is what I want to show you, the subtle distinction. If I put these in right now for the operation that I'm doing, remember, I'm just drawing the contours from a tin file. I'm not actually doing the triangulation. If I do the triangulation and I put these in as exclusion perimeters, then it won't actually generate the surface underneath there. But if I allow it to go across and I'm just drawing the contours now, then what we wind up with is this. So here are the drawn contours, and you can see up here where the buildings are, you don't see those contours in there. But if we add the surface, you see the surface is actually complete in there because when I triangulated it, I didn't have the exclusion. But when I draw the contours, they go here. Another way to verify that, I go to my surface menu and choose my surface inspector. If I can. We don't have it on that menu there. Let's see. Inquiry. No. Survey. It's this tool right here, the surface inspector, but that may only be for civil. Do either do either of you two or neither of you two, do either of you have the civil module?
I do not.
You do not. Okay, I want you to try this. If I run that command from here, let me see. I'm curious as to whether it's there. It's a command called Surface Inspector. If you type at your command line, SURFVALS, the same thing you see down here on the bottom of my command line,
Huh?
does that run or does it say unlicensed? This type this word right here.
It says the requested module is not installed.
Okay, so that's only from civil. Well, all right. So let's see another method of that. If I, let's see, make the grid to surface volumes by draw surface spot elevations. I draw spot elevations. Single surface file. My surface, I wanted to see. Yeah, okay, here's what I was looking for. So when I move the crosshairs around, it's reading the surface, and you see that elevation is changing. And if I go over in here and I look inside the building, you see it still has elevation in there, even though my contours didn't draw. So when I used those as exclusion polylines, all they did was clip out those drawn contours. If when I built the surface, I said use those as exclusion polylines, and if I hovered the mouse in that area, that elevation label would disappear because it's undefined in there. Same as if I'm out here on the outside edge, you see how see it stops when I'm off the surface. I come back in, I have no contours, but I've actually got surface out there. Remember, I just drew it to these new shapes. Okay. So just keep that part in mind. I'm going to just interrupt that command. And that's the nitty gritty, the ins and outs of modeling your surfaces and how you do it. So we're going to take a look at, for the rest of our afternoon, we're going to go through a little simpler thing that will help us sort of tie all these concepts together. It won't be as nuanced as all of this, hundreds of contours and little tweaks and twirls that you're going to see. It's going to be a little simpler to understand process. Okay, so you can save that file if you wish, if you've made some changes or you've gotten some if you've gotten the gist of what we're doing, and you can always recreate that from your data sets, etc. Now, one of the things I also wanted to show you was the differences in that shrink wrap and that boundary polyline stuff. So I want you to do this. Go off to the side over here, just in some empty space, and let's go to draw rectangle, and just draw a rectangle. Repeat the command and draw another one, sort of like this. And Let's draw a 2D polyline. Sort of like that. Maybe draw another one that looks like this. And what the heck, let's draw a circle. So I'm going to pick a point here and just make that into a circle. Now I'm going to also change the color here just to help us keep track of what things are looking like. So you can see the net effect of all this. Now I'm going to switch my color now back to being white, and I'll keep that as a heavier boundary. I'm going to change all of these line weights here now to be a little skinnier. All right. So just draw yourself some geometry there. Now I want to show you the effect of a couple of tools here. One of those is that draw shrink wrap entities. It's on the draw menu. There it is. Looks like a gift box, a birthday gift that's been wrapped. It's also on my draw toolbar right there. See that same icon. All right, now here's the two choices: across gaps or bounded line work only. We did this across gaps over here when we gathered up all that data that had those open spaces between the ends of those lines. So if we leave it as across gaps, we'll set our perimeter reduction to none, and that wants us to select the things. I'm going to just do a crossing selection on that, and it does nothing. Okay, great. If maybe it's not that new gap, just maximum gap is sort of throwing things off. I'm trying it one more time. Say 10,000. I know it's not any bigger than that. Oh, right here's the problem. I said ignore zero. These are all sitting at zero elevation. That's the problem. So I'm going to uncheck that ignore zero elevations. And I'll draw this. And there it is. That's what I wanted to show you. And I'll put this now in the background so you can see other things across it. So you see that original yellow line, the original red rectangle, the blue rectangle, and this magenta line, but you see the red line that went and it jumped across the gap. So it allowed it to go across the gaps. And that's why it came down here and it went out to this thing and then came back to this corner and then shot all the way across to here instead of coming over here and walking up that edge, because our reduction was not so great. If I select this, delete it, repeat my shrink wrap, and I'm going to change that to a high reduction. And now you see when it comes around here, it tightens it in real quickly. It doesn't jump all the way across here. It tightens it in because I've done a higher reduction to get out here across the gaps. Now, notice one thing you might notice is that this circle doesn't get included with that. One of the reasons I drew that is to show you this. And that's because if you look at the command, draw, it says shrink wrap entities. And you look at the command down there on the command line, it says SWP lines. So I'm going to shrink wrap polylines. And that's really what it's looking for. So these, and it doesn't tell you there, but the stuff you select needs to be polylines or points or lines as well. But it won't do circles. If I select that and look at its properties, let's see, that's a circle. So it won't do circles, but I've got a real quick fix for that if I wanted to make that happen. And that is this. Under the edit menu, if you have anything in your drawing that needs to be turned into a polyline, You don't have to run p-edit and say, yes, create and all that. You go to the edit menu, polyline utilities, and you say entities to polylines. And you say yes, and you can say select lines, arcs, circles, 3D faces, ellipses, splines, any of this stuff. So I'm going to select that circle and say, okay, and now it has created this as a polyline. And I'm going to put that size back to here. So even though it's, got the points, it is a 2-segment polyline. It has a start. It is an arc segment with a midpoint to the next vertex, another arc segment with a midpoint over to the same vertex, and it is a polyline. Now, when you go to shrink wrap, we'll just keep everything the same. We'll select the stuff, and now you see it actually gets recognized and it's brought into the game. All right. Now, that was an allowable gap that it let it go through and find the circle before it came all the way down here and came out of that. A couple of ways I can fix that using these same parameters is if you shrink wrap these polylines and tone down that gap a lot. Let's say I make that 2 feet and select this, and now you're going to see how it comes down and it tightens itself into it and goes all the way around it. But it couldn't go from this corner all the way out to this corner because that's greater than 2 feet. So that forced it into coming down here until it hit it, and it tried it again. It's still greater than that distance, but it found this out here because it's coming down here, it hit the edge and started, working its way around. Okay, now that has the same effect. I'm going to erase this and delete it. As if you run this command in this fashion. If you draw shrink wrap entities and say, I'm going to put that, say 25 feet. No, maybe I'm going to leave it at 500 for now. And that part doesn't matter. But if I say bounded line work only, now notice all this stuff grays out, it goes away, so it doesn't matter. And if I do that and then choose, it has that same effect. It runs till it hits an edge, that blocks it from coming to the inside. That's why these lines that stick out over here are not included. But when it comes out and then comes back in, you see that forms a boundary that with this blue rectangle so that it forces it to walk around that edge, but it doesn't go up and walk around that corner. Now, what practical use is any and all of this? And here's the answer to that. Let's say you've got a big, a construction area project, or maybe, a subdivision, and you've got some properties, maybe these 3 lots, 3 or 4 or 5 lots up here in this particular block. And you want to, only contour in that area, or you want to find out what is the total area of those parcels all gathered up together. So if you run shrink wrap polylines and just let it go across bounded line work at this point, and if you select just a couple of things, well, that went all the way around. That actually generated the 2. It's really what I was looking for. If I did say this one and this one, so there now has created a combined total area. So maybe that's a phase 1 boundary and a phase 2 boundary for an environmental, or not environmental, but for a construction phasing. And I wanted to see, what's the total disturbed area limits? And even though those two boundaries might intersect and overlap and it's just as if I took something and drew around the outside edges. Now I can select that entity and look at its properties, and I see it's got an area 105,493.15 square units or square feet. So, I can use that to then, do reports, or, I could use it, say, and generate an index sheet for a bunch of sheet boundaries if that's what I had going on. So there's any number of things you can do with that shrink wrap polylines. So one more time. And we'll just grab them all. Now, that is the result of shrink wrap polylines. I'm going to turn this dark blue so you can see it. All right. So that goes around the outside, either by across gaps or across bounded line work. And what I want to point out to you is on the draw menu, right above that command is this one that people get confused with. This is boundary polyline. No, boundary polyline is a CAD only command. It has nothing to do with Carlson. It's just unfortunately right beside it here in the menus. But what this is from the inside out, whereas our shrink wrap polylines is from the outside in. You can think of the boundary polyline as if you're standing outside of all of these things here, think of them as looking down on walls. And you're on the outside and you just cut loose with a water hose spraying blue paint. Then it's only going to hit those walls on the edges, and see, it's not going to go inside and get any of that. So it's going to spray all that around you and find it from the outermost sides in. The boundary polyline goes from the inside out. So I'm going to take this and just move it up here out of the way so you can remember what that original shape looked like. Now, from the inside out is as if you're standing in the interior of any of these spaces, and you cut loose with a spray gun of, a paint gun, and you start spraying everything that it could hit, or you let a paint bomb loose. What walls is it going to find? And this is the exact same thing that happens if you hatch these entities, is it creates that boundary of a hatch. It's called a hatch boundary, and that's what you're actually drawing, is the hatch boundary. That's why it's called boundary polyline. So if I pick that, and let's just put this back on our same 2D, and then I say pick inside, and if I pick in this spot down here, you see what it does? It finds the innermost area. I can come up here and pick in this one, or down here, even out here. Okay, so that goes from the inside out. Let me get all these out of the way. So even though it sounds like it's the right command that you want to use, you're trying to create a boundary polyline. It's not the same thing. So that's a means of going from the inside out. Shrink wrap is from going from the outside in. And so, and again, use them for all kinds of different things. If you want to composite areas, you got overlapping, phase boundaries and such like that, just shrink wrap it and look at that as an overall outline package. You don't have to draw polylines, snap to the corners, snap to the intersection, snap to the intersection, snap to the next corner. You can do all that. It doesn't matter, but you don't have to. Okay, that's the point of all this. Okay. So that will wrap that part of that deep dive up, and let's pull back out a little bit and view this from a little higher elevation, a little bit less in the weeds, so we can sort of internalize what's going on. First of all, at this point, any questions? Any, I wonder how, I wonder if, what do you do in this case? Anybody?
Not from me.
Okay, everybody looks good. All right, perfect. We are going to, oh, while we're here, sorry, I keep bumping into these things, but it's something I told you I'd show you, BB, especially since you use the GIS module. We'd go ahead and get rid of this pink stuff. And I'm going to turn everything on and then freeze the break lines. And this is essentially the file they delivered. Now, let me just do that one more time. And get those little spot dots off. Speaking of which, let me also make sure I put my point style back the way I like it. There we go. Now, one of the things as you're working too that can be really helpful if you're starting to build this thing is if you have some aerial image to go with it. Now, if you have an actual ortho photo that was produced photogrammetrically, and it has, you know, projection files, what they call world files, that tells it the coordinates of the pixel, the lower left pixel, and the rotations and all that kind of stuff, and it will line up exactly tight as a drum. If you don't have that kind of stuff, there are some other avenues that you can use. And let's see, on the survey menu, there is a GIS module, or in the survey module, there's a GIS menu. And you can do a couple of limited things here, like you can import a shapefile from Esri if you happen to have one. You can look at some different images, but you can attach an image or a document to an entity. You can convert what are called MR-SID images. Everybody calls that Mr. SID, but it's not actually what it stands for. And you can place an image by a world file. So there's, if you have that typically ortho rectified photograph, and it comes with a world file that tells it how to rotate into your space. We don't have that for this site, okay? But with the GIS functions that are available in survey, even with that, I can't do anything with it, okay? But if I have the survey module, and I'm going to switch to that, I'll go to settings, Carlson menus, GIS menu. So now file, edit, view, draw, inquiry settings, and points are still the same, but I've got GIS and a little bit more. And I've even got this images pull down, and I can do a couple of things with these images. I've got the same one, an image world file, where we place, you know, we can actually build world files. I can place an image by the world file. That's the same command you saw back in survey. I don't have that, but I can also place a Google Earth image. Okay. Now, it's not going to be exact, certainly not survey grade, but I'm going to be able to place that behind to sort of help make sure that I'm creating my base map correctly. So the first thing it's going to ask me for is to give it a file name, and it's look at the stripe above. It says select output file, and it can be a JPG, a JPEG, a PNG, a TIFF, a bitmap, a BMP. I'll keep it a PNG just for yucks. It doesn't matter. And I'll call it, by default, it's using a JPG. I'll switch it to that. I just happen to like that format better myself. I'll say save. And it says, do you want to pick from the screen or use a map? Now, this has to be done. You have to be geo-referenced. You have to have this in like state plane coordinates, which we do. And if you said you want to pick it from a map, it's going to load up a map browser through an interface browser and all of that, and let you choose how much you want to bring in. But I'm just going to say from the screen, so I have to answer that question. And so now it asks me if my first corner and my bounding box and my other corner. So I'm just going to go up here, pick, and I'm going to choose the types and the resolutions. High resolution if it's available. What map type? I've got road maps, aerial photography, hybrid maps, which are aerial photography with road names and lines and stuff overlaid on them. So let's maybe think of that. Or there's terrain, which will show me the hillshades and the contour lines. Sometimes they're taken from quad sheets. Well, I've got my terrain, so I'm just going to leave it as hybrid. You can set the layer. It comes in with its own defaults. Tell it to place it in the background so everything is on top of it, above it. I'm going to say okay. And it's going to go out and connect to the internet and bring down anything that it finds from those Esri servers. And there's your photograph. I mean, from Google Earth servers. So there's your photograph sitting in the background, underlying our mapped area, which is not terribly bad. Looks like it fits pretty well. You see, but if you zoom in a little closer, you're going to notice things like, in fact, let's take this image. I'll select it and I'm going to tone it down a little. I'm going to give it some fading here, say like a 40% fade, so it gets a little darker. Now, I'm going to look at this and see that, well, here I see in the photograph, you see that edge of that curbing, which is outside this set of pink lines and this green inlet, which really should be up here. You can see it in the photograph. So it doesn't line up exactly. And that's just simply because the Google Earth imagery is not ortho-rectified. Here, especially, you can see the difference on these parking lot edges, you see. Now that should not make you think that your survey is wrong. That just says the photograph wasn't correct. Now, what do you do about that? Well, there's another module called CADNet, and that's available. You can look at all that, consider that with your company and with your vendors and whatever, but it's called CADNet menu. And so it just switches a different set of menus. And now there's a menu in here called raster that will work on raster images. There's PDFs, there's your BIM. I think one of you might have mentioned using some BIM products or BIM import. That might have been somebody else. I apologize if not you, but anyway, it has support for building information management. But if you look on your, well, you probably don't have it, but if you see what happens on this raster, adjustments, you've got things like you can remove speckles, de-skew if it's twisted, and these are just, you know, it just works on the image pixel by pixel. But the one to really focus on is this rubber sheet. And this is why the image that you have now behind this is not ortho-rectified. And this is part of the process of ortho-rectifying. We're not going to go through that whole process, but this will help. It'll show you what this can do for you. So if I choose that, and I choose a method, I'm just going to use the inverse distance. That'd be fine. Let's say, okay, I'm going to turn off my snapping for right now. So now it wants to know, pick the origin of control point 1 and then a destination. So I'm showing it in the photograph a point. So that back corner there, and where do I want it to be? Where's its destination? Right there. Now I could snap, but I can't snap to the pixels of the image, but I'm going to get this, you know, identified for some of these hard corner edges that I can. And the more you put in, the tighter the fit it will get. I could go, let's go back over here to this area here. I'm going to go from this back corner of that inlet to here. let's say maybe that corner of that inlet to right in there. Maybe come down here and so sort of spread the wealth out a little bit here and get on, all the parts of the photograph that you can identify. Buildings are not really good to use because you're looking at the tops of the buildings and there's a certain amount of building lean in the photograph. And what you need is to be able to see the ground position. So here's a good potential spot, say right in there, needs to be right there. Here's a good one. So right there, that really needs to be moved to here. Now, that's probably sufficient. Maybe one more in this corner if I can find a suitable candidate. Oops, sorry. Hold on, come on. Let it redisplay here a minute. So there we go. Maybe there goes to there. All right, so anything that I can use to match up, and the more you do, the better it's going to, the better the fit will be. Maybe one other good spot. Can't really tell where that pole is in the photograph on the ground to bring it back to where the symbol is, but just things like that you can identify and that you can use. Here we go, one last bit of that corner of that pavement right there to go to right here. All right, so you hit enter, and when you're done, when it's done, you're going to see it shift and it warps the pixels of that photograph. And did you see right there how it jumped? You saw that curb line now, how it jumped into place. So now if I look at it all around these other areas, even places where I didn't put a control point, now you see how that lines up really nice. So it just warps everything into place. And like I said, the more of those control points that you can use to help rubber sheet that. See, now that back corner fits nicely there, Everything here, you're going to still probably find some areas that are slightly off, but that's a way to use this. And now this thing's probably close enough that I could start, with some fair amount of confidence, drawing things like paint stripes on my parking lot. If I see, well, hey, there's a photo, look, there's that inlet. You can see the dark part where the inlet was. So you can, and there's a perfect example right there. They just sort of brought this outside edge. So if you needed to have these stripes brought in there, you could, do all that kind of stuff to sort of help finish out your work. And we do all that without needing to have those ortho photos because they're available. And the manipulation of the image, once you're done with it, comes, it comes in not all that close. And remember, that's just a Google Earth image. But if you do have the orthorectified photograph, you could use that with a world file, and that will be exact. This helps to get it a lot more exact. And like I said, I've got enough control in there now, and the fit seems to be, really nice. There's maybe I would go back and do a little bit of an adjustment in there, but you can see, there's that retaining wall, and it's drawn, it fits in there pretty nicely. Okay, so those are some of the tools that you can get. The first one is from the GIS module, and that was allowing you to place the Google Earth image. And that goes out and reads where you are, your coordinate space, and it goes out and grabs it from Google Earth and brings it in. Again, we know it's not exact, so we go to CADNet and we do that rubber sheeting. Okay, so that's one method. The other couple of things that you have, I'm going to switch back to GIS that you not only can bring in. Now, BB, do you do a lot of GIS work? Are you, familiar with GIS databases and such?
And not in Carlson, we doing a
But-
lot of it in Civil, but not in Carlson.
Yeah, but I mean, just in general, like if you use ArcMap or ArcGIS from Esri, or you use other tools, you're familiar with the data that
A little bit. I wouldn't say like a lot, a little bit.
yeah, so like, you could bring in, zip code boundaries, or you could bring in a subdivision map, the parcel map with, parcel numbers and landowners and all that kind of stuff. And all of that data can still come into the file here if you needed it, wanted it to. But a couple of things that you have available with that GIS tool, and I'm not trying to make this a GIS class, I just want to point this part out, is that you've got these WFS servers, the Esri server, and you got this what are called REST services, or REST servers, REST. And they're usually hosted at universities. And if I choose that, for instance, this comes from West Virginia University, and these are the 2-foot contours over a 3-county region. So I can choose those, I can set up a new service with a different location. So once you get those done, it's just like going there on the internet to those GIS locations, downloading the data, and then bringing it into the drawing, but it just puts it all in one spot. So one of the things that's there just out of the box without you having to do much is this import, these Esri ArcGIS services. Now, obviously you can bring in shape files, geodatabases, and export them, but we're not using Carlson as a GIS system. But if I wanted to bring in this ArcGIS services, it's going to, you notice they said downloading, please wait. So what it's doing is it's looking at where I am in the world, and it's going out there and finding all of the publicly available stuff that it has for me to be able to use in this location. I've got a layer, I picked from these layers, and I've got several. I've got, what is that? I've got the world imagery, dark gray base, reference, light gray base and reference, hill shade, ocean, Antarctic, Arctic, world boundaries and places. Now, I'm obviously too small to worry about seeing that, but if I was, soil survey maps, I don't know that there's anything within this region. I'm going to back up and give it a big enough area. No, see, it said it couldn't get anything from the source, so it didn't find anything in that regard, or in that location. So really what I'm almost always going to see when I'm in this tight are the world imagery, maybe even the street map, but I don't really even have a lot of, let's see, let's try the street map, and we'll get, see if I can get enough out here. See what it finds for us, if anything. And again, all this is doing from this particular service is it's bringing down images. It's not bringing data in. That's what those import shapefile, import geodatabases, those actually bring in data and creates drawn polylines, points, polygons, that sort of stuff. This is going to bring in images so that I would have to trace over top of if I needed those actual boundaries or find a different location. All right, so there's my soil boundaries map, or no, this is a street map, sorry. And you can see here, that's my Lincoln Highway, US Route 30, South Breezewood Road. And there you can see, hey, those line up pretty nicely with my say my building. There's my building outline. You see, it's not exactly that, but again, we're not far off. And you can see those structures are, you know, pretty well represented. So it's just a way of, you know, making sure you've got, you know, you got things in the right ballpark. And if you needed to add in some of this peripheral information, you could do that. And you would either take the effort to get it rectified into the right space, or you'd live with it being this enough. If it's like soils boundaries or watershed boundaries, things like that, I wouldn't worry too much about, you know, where it lands and how tight it is. But I just want you to be aware of what some of those other modules can do for you. Okay. You all have the GIS, and with that, and what I did was simply from this images, place Google Earth image. But there you've got all of these other things that you can actually get really tight fit if you've got the data and the world files. But I didn't have any of that handy. I didn't care. I just plopped them into place. And then I used my CADNet tools to do the warping. And, you know, that served my absolute requirements. And, you know, I was able to move on downstream with what I'm working on. Okay. So with that, it's time for our last little break, and we will come back here. Let's come back at again, full 15 minutes. Let's come back at 10 minutes till the hour, and we'll then spend the rest of the time going through the process of a simpler but more complete, let's say, not as deep but much broader workflow. So you can tie together some of these things you've learned all the way back to using points. And then we'll see a couple of new things like computing volumes, and then we'll draw contours, and we'll do all kinds of things that sort of help tie it all together. Okay. Any questions?
No.
Good. All right. BB good. Mike, you good?
I'm good.
All righty. Well, I will at this point pause the share, and I will pause the recording. Turn. All right, so let's wrap all this up with a start to finish type of workflow. So we got a situation here where we have, we're going to open up a drawing, and we're going to use that to create a little site plan, little grading plan, and see what we're going to use to, you know, turn that into our modeling and everything that we're working on. So let's open up a drawing, and this is starting on page 37 in your book, and this drawing is going to be called example1.dwg. And we're going to say open files, and we're going to find that example one. Now there is an example one completed that you can look at for reference, but we're going to start fresh with example one and choose open. And you should see something like this. I'm going to do a zoom extents. I see there's nothing else there. I'm going to make sure all my layers are turned on, do another zoom extents. Nothing else appears to be in the drawing. You could go through the file, drawing cleanup. One of the things I like to always check is this elevation range. So I clear everything. I turn that on and say scan the drawing, and I make sure I've got numbers that look reasonable for me. I don't have any real extreme outliers, so I can just cancel that. All right, so I've got things here. And if I look around, I see I've got a bunch of points. I've got points that have point numbers, elevations, and descriptions, and I've got a description of B. Looks like everything in there is B. And then I've got B-toe. So that looks like it might be a clue. So let's list our points, see if we've got anything else that we might have overlooked. We go to the points menu and choose list points, and now what happens? Well, it's asking for a coordinate file. And we don't have one. We don't have one associated with that file yet. And I look in here and I don't see one, and I see like these exercise ones, but those are the things we did earlier during the week or earlier yesterday. So I need to make one. And so I'm going to go to my new tab, and I'm going to let it just keep that same file name as the drawing file. That's fine. We'll just call it example1.crd and we'll say open. All right. So now I've created a file. If I want to list the points, I see that it has 0 points in there. Well, how do I get these points into that coordinate file? You guys remember that? Any volunteers? Tell me what command to use. Well, first start with what menu do you think I'd look under?
Yeah, because she just.
I'm sorry, I didn't hear that.
Man, I'm stumped on that one.
All right, so
Isn't
go ahead,
it
Mimi.
like update the CRD from drawing?
Exactly right. But the first step is to figuring out which menu you might want to look at. So Mike, to help you think of that process, what are we dealing with here?
Coordinate utilities?
Yeah. But so the menu that it's on is the points menu. That's what I was getting at. So we're going to look
Okay.
at.
Oh, okay.
Yeah.
Okay.
And so what are the tools there? Now, where we're going to find it is either in that command, which has a bunch of commands in it, or you can come down here to the bottom and pull that out individually. Doesn't matter. I like to use this little utility bit because I can see some of the other things that might also apply at some point. So now, see, it's telling me my highest point number is blank. There's nothing in the file I'm in now. So what I want to do is over here on the file half of my utilities dialog, I want to update the CRD file from the drawing. Okay. And so these are, now you can have, these are some custom attributes you could use if you're using different point blocks and all that, but just leave those as they are. That's your default that it's going to take. And we're going to update the point descriptions as well. And which descriptions do we want to get? We'll take them all. So we have an asterisk, meaning everything, and we'll say, okay. And now I want you to select entities. The line above says select Carlson Land Development Desktop Soft Desk, and all these different types of points. Well, these are Carlson points. So I'm just going to draw my window across them all, finish my selection set, and boom, they're in there. Now I can exit this, but while I'm here, I'm going to go ahead and list my points again. And this time now you'll see, hey, there they are, B toe, and B. So those are the only two descriptions I've got. All right. So now I'll exit that. Now, one thing you might want to do to help on this is let's make a couple of point groups. So we go back to our points menu, do our point group manager, and we'll create a group. And this group, and I've noticed all those B toes are around the outside perimeter of this thing. So I'm just going to call these toe. And that's really going to be the toe of slope because that's a stockpile that you're looking at. So I'm going to uncheck include all, and I'm going to click on description down here, and I'm going to say start with anything but include toe. So that will get B dash toe, and if you had other things that ended with toe, that would find all of those. I will then save. So now you see over here in my list, there they are. I'll make another group. I'm going to call these interior. And these are my interior points. Oh, let's go ahead and include them all, but let's exclude. It's a different way of doing it. Star dash toe. So it included all. That's the way I defined it. And I could have just as easily unchecked that and just put in the B by itself with no asterisk. But I said, go ahead and include all, but I want you to exclude out all the ones that have toe on them. Either way does the very same thing. So now I've got 2 point groups, okay? All right, so. Couple of other tools here. If I'm looking at this as a bunch of points on a stockpile, I know I'm going to probably need to model that as a surface. So what do we know we need to do to model the surface? We basically have things at elevations that we're going to be using, in this case, just points. And so we're going to say, triangulate and contour. We can just, take our chances on it and see, but you got a couple of places in here where you'll get those little triangles, and up in here in this area here too. So we have points called B toe that go all the way around their perimeter, and that should be our limit, our surface limit, or that inclusion boundary. So how do we do that inclusion boundary? Remember, we got several methods. We can run the triangulate command and let it do it. We can draw with shrink wrap. Let's do that one. Let's go to draw menu, shrink wrap our entities. We'll allow it to go across our gaps. And let's go ahead and see what happens if we leave it on perimeter reduction of high. And we say, okay. Just grab everything and see what happens. So now we've got a line that do around everything here. It looks like for the most part it was successful, except look right here. It included this point when really that's not a toe point. So you could do something like this and remove that vertex. So that's fixed it right in there. And then you just sort of, walk around and see what's happened. We've also got some places up in here, probably. There's another one. And it might even be that there's another one right in there. So we could do that. Now we've got all the toe points connected. That's a way of doing it. It's simple to do, okay? Let's look about a couple of other different ways of doing that. So I'm going to delete that line again. I'm going to change that layer so you can recognize it when it draws it. So what else could we do? Well, we could look at this and say, well, there's point 2015, 2014, 2013, around 16, 17, 18, 19. So it looks like they're in sequence. And if I look at my points, list points, or even, let's just list a point group. Let's just list the toe points. And they start with point number 2000 and go down to 2028. So you could do this probably as a quick way of doing that as well. Let's draw a 2D polyline. And let's put this on a layer. Well, let's just leave it as clipping boundary. Set this color to be by layer. That would be fine. And that's okay. We'll say okay. And now it says pick a point or point numbers. Remember, we can use a range. So I think 2000 to 2028. So that
Sure.
goes,
Translate into which language?
shut up, Siri. Sorry, I said something that triggered Siri. All right, so that now has gone from the start, it went to the end, and to finish that, I just down here at my bottom, I see that option to close. And so now there is that. And I wanted my line weight to be updated. I must not have. Well, it says it did. Oh, I'm not displaying my line weights. There we go. All right, so that's another way. That's probably the quickest way that I would have done it. Let's look at a couple of other ways. You can go to draw polyline by nearest found. Now that would work. Well, let's just try it first. Now do a 2D and we'll put it on that same clipping boundary. Maximum separation. Now you could say, leave everything like you see it, description match as asterisk. We'll do, tell it how you want to select it. So from the screen, now we select our points. Now if we do this, now watch what happens. So wherever it started, it went to the nearest point that it could find to start connecting these up. And now it also worked like when it gets here, you know, that distance may or may not be shorter than this distance, but if it's already been used before, it doesn't redo it. Well, that was obviously of no use for us, okay? So let's repeat the command. And that was draw polyline by nearest found. And this time, instead of all, I'm going to say all, but with TOE on the end of it. So it's only going to find the descriptions that include anything and end with TOE. I'll say okay. Choose by the screen, select, and off I go. And now that looks like, and see how it misses that point, and it finds those points, and it gets all those together. Now, what I need to do though, to finish that up is I need to select it and go over here into my properties and change it to yes, closed. So it puts that closing segment in. Okay, so that's a way of doing that. Now, as an alternative, just select everything and delete. Clear out everything. We've got our points in our file, so we can use them again. So we could simply draw locate points, and this time let's go down to the bottom and say draw point group and just draw the toe points. And so now you could go back and do that shrink wrap boundary, and we won't pick up those other B points, or you could do that same one we just did a minute ago by nearest found. And at this point you should be able to do it here. And if I say choose from the screen, so it's not reading numbers out of the coordinate file, now that does the same thing. Okay. Now, what you may find sometimes in a situation like this is that, you know, maybe it comes down from here to here, and then it finds another point like right in here that's closer than this point, but it really needs to go from here to here to here to here to here. And at that point, you would just do, you know, you would just move that location and maybe add a vertex and stretch it over to the other point that you need to mix. So you just, you know, manipulate that any way you need to do. So however you'd like to do it there, I'm going to say, yes, it's closed, and that's going to be my boundary. Now, right now, that is a 2D polyline. It has 0 elevation. If, however, I wanted to make that into a 3D polyline, or if I wanted to draw that initially as a 3D polyline, I could do it like this, and I'll show you the advantage of doing that in a minute. So if I go back to draw polyline by nearest found, I'm going to make it a 3D polyline. I'm going to say okay. Choose by screen and select everything. It's there. I'll choose it and say closed. It's there. And now when I look at this thing in 3D, so I'm going to select everything or go to my view, 3D view, drawing viewer, and I'll select it all. And if I look at that now, I see that yes, indeed, it is 3-dimensional, and it goes, you know, point to point to point. Everything's good. Now, the reason I'm going to make it a 3D polyline is when I go to build the surface, that's going to be just the bottom slice of that pile. So it's going to go from edge to edge and not include any points in the middle here. And you can do that several ways. You could turn off the points except for these ones, choose those points and let that be what it builds the surface with, or you could simply select that line. As long as it's got elevation, which it now does, it doesn't need to even bother with reading the points. So that's one thing I'm going to do. Now, because I have that as a 3D, I'm going to select everything. I'm going to hold the shift key and click the line so it's deselected, and then delete that. So all I've got in my drawing now is this three-dimensional. I'm going to go back to my points, draw locate points, draw the point group, and this time I'm just going to do the interior points. So now there's where they fall. So now I've got all that I need to do to build this surface. Okay, actually two surfaces. So let's do that. Let's build the first surface, which is going to be on our surface menu. Go back to my survey menus, triangulate and contour. And I'm going to, on the triangulate tab, I'm going to say write the triangulation file. And I'm going to select and choose a file name for that. And I'm going to call this SP for stockpile dash base. I'm just building the bottom as if I picked that stockpile up and sliced off the bottom piece of it and made that into a surface. You'll see why in a minute. So I'll save that. I will use inclusion exclusion areas, which won't have any effect on this one right now, but we'll still use it. I'm going to make sure my erase previous is turned off, because later on you'll see why I want to keep that done that way. Now, let's go ahead and turn densify break lines back on. We'll go every 5 feet, so it'll put points along this in memory as it goes to build things. And we're not going to minimize flats because most of this stuff are going to, they're not going to be necessarily flat at the level, because that could be on a sloping hillside. We don't know yet, but I don't want to eliminate the possibility of forming flat triangles if they are indeed flat. So I'll leave that off. And I'm going to go to my contour tab and uncheck that. I don't want to draw the contours just at the base. I don't need that part yet. I'm going to double check on my selection tab to make sure I don't have any filters set. I usually don't. So that part's good. I'm good to go. I'll say, okay. It says now select the inclusion perimeter polyline, which is this outside one. I've finished that selection. Now it says select any exclusion perimeter polylines. I don't have any, so I'll just say enter. Now it says select the points and the break lines to triangulate. Now this is whereas if you had those other points out there, you could have left those on and selected those points, but because this line has elevation data in the vertexes, in the vertices, I'm going to simply select it and hit enter. And it tells me it wrote that file. I'm going to verify that by viewing it in my surface viewer. There's my SP base, and you're not going to see much. You'll see the triangles that formed, and you see they're long going edge to edge because there's nothing in the middle, and that's okay. That's what we want. But we're going to flip it up and make sure there's no sort of gotcha areas. You know, you got a few in here that might, you know, you might be able to fix a little ripple there. But to be honest with you, we don't have enough information to do anything about that, to worry about that. Oh, and if you were curious, you could show the contours, and let's show these at every half-foot interval. And let's go back to our surface properties and change that color back down to 95. Or 83 is fine. So there you can see, there's your half-foot contour intervals, and what you can see right in here, some of those long skinny triangles, you might need to change the way they run, which you could do by this, if I turned on my triangle edges, and so if I change the orientation of that, or watch the contours and the shape of the surface, you see is going to change for me. Now, I don't have any justifiable basis for having done that in that fashion. But that's, some of the edits that sometimes people will make. They'll look at these little bent triangles and they'll try to, fix the shape of those contour. So notice how the contour noses are changing. So don't get hung up on that though. Like right here's a spot in here. That say maybe that one's a little out of whack and maybe that one's out of whack. So you can do a couple of things if it makes sense, but I wouldn't spend a lot of time and effort trying to resolve those when you're just doing something across this base of the stockpile. See, you can chase that stuff all day and sort of make yourself crazy with it. All right, so I'm going to exit and I'm going to not save the changes. So now I've got a base surface that's just the bottom slice. And why do I have that? Is because I'm going to make another surface that includes all of the points in the middle as well as the outside toe of the slope, and call that my stockpile. And then I can compute the volume of that stockpile because I have a bottom surface and I have a top surface. And it just subtracts the differences between the two and comes up with my amount of earthwork. Okay, so let's build the next surface. We'll go back to surface, triangulate and contour, and I'm going to change this file that I write. I'm going to choose select, and I'm going to call this SP. Just call it top. I'll leave everything else the same. Still not going to draw the contours. I'll draw those here in a minute. I'll say, okay. I'll now choose the inclusion, no exclusions. Now select the things to triangulate. I need to make sure I get that line again because that has my point data in the vertices. And then I'll get these other points. I'll hit enter and off it goes. It creates the file. I will view 3D view, surface viewer. My SP top now looks like this. And if I go to settings and turn off my triangle edges, maybe change my light source and things like that. So that would be, and the contours that you're looking at now are your 1/2 foot contour intervals. If I set that to say maybe be a 2 foot interval, you can see it's pretty shallow. And there's a point in here that may or may not be very valid. I mean, it's part of the data. And you can see that when you look at the triangle edges, see that, you can see how that contour comes and wraps all the way around up here because the elevation of that point was such that it tells it that's what it looks like. And maybe it does. So I'm not going to mess with this any too much, but you could do things like, you see this contour, and I want you to resist the urge to do this. But if I swap to 10 edge, now watch the shape of that contour. See, that radically changes that. And maybe that's what it does. Maybe it doesn't. If I change these, I don't know. I don't have any basis for saying that. I would really need to have surveyed it a little more closely. See, so I don't really know. And I don't really care because this is a stockpile. If I'm off by a wheelbarrow full of dirt, it doesn't matter. Okay, so now I've got two surfaces. So the very first thing that, maybe the only thing I need to do is figure out how much material I've got out there in my stockpiles. So I've got a bunch of points. I went out there with a rover and strapped a GPS on, like on the back of an ATV, and I walked all over, got these points. And so now I want to see what's my volume in that stockpile. Well, if I go to surface and I choose volumes by triangulations, I've got one surface volume or two surface volumes. Now, one surface volume can give us the same results. We're going to do several of these. I'm going to look at one surface volume as if I did not do the base. Okay. So it says to select the triangulation file. So I'm going to use the top. So now, what is my reference surface? Now I can do a set elevation. And if I look at those elevations, I go from like 399, 98, 96, 395. I could find the average or something like that. Let's say maybe 395. So if I just put 395 and said, okay, any inclusions and exclusions, there's no need to even worry about it because it stops at the edge of the surface anyway. Shrink and swell factors. I want to look at it in cubic yards as well as square foot areas. You could report tons. Let's say if you knew that was coal and you had it as an 80 pounds per cubic foot, you could do that and say, okay, and there's your report. Okay, so I'm going to put this one on the screen. I'm going to choose this icon here. I'm going to go out here and I'm going to put it right there. So you can see there it is by a one surface triangulation. Okay, so it shows me there's my surface, my SP top, and my elevation of 395. In fact, I'm going to just edit this and take this all the way out to there and get rid of it. Oh, actually, I'm going to get rid of this extra bit too. All right, so there's that report. Now, what does that report do? I'm going to display my last report here and show you what some of this stuff does. It shows me here's how much cut I have. 2,700 yards of cut. Now, it's really fill if you think you're going from the ground up, but I just looked at the one volume. So to take that down to this elevation, I had to cut this many cubic yards. But there's also a little bit of fill because that number, you know, is probably not down at the absolute bottom of that peripheral. And keep in mind, this pile, if I give it a reference elevation, I'm assuming that that's level ground that it's sitting on. But what if that's sitting on the side of a hilltop, or you know, a side of a hill? There's a sloped bottom to it. That's why I made that bottom surface, so we can do that. Now, that gives you some averages, ratios, et cetera, right? And you can look at those at your leisure. Now, let's run the command again, surface volumes by triangulation, one triangulation surface volume, same surface. And this time, instead of an elevation, let's use the 10 perimeter. Now, remember, we built that surface using that line out there. And so that's its perimeter. And it's going to use that. And it's going to do, you're going to see here, I'll just leave everything the same. I'll hit OK. I will output to the screen. And I'm going to go over here and plop this one down in this spot. And I'll edit this, take the long parts of the stuff out of here. All right, so now let's look at the differences. So now it's flip-flopped the cut and fill because it recognized that it's actual fill. And it's saying, well, if I cut, I've got just a yard and a half or so of cut and mostly fill, 3,300 yards of fill. That's what I'd expect. Now, the reason this is slightly above zero is because there's a little wrinkle in the base right up here. Remember those little triangles that did that? It's because this outside point is sort of up in the air a little bit. So I'm going to call that, good enough. I'm going to report this as, 3,300 yards of material that I have. And if it's coal, I know that I've got, 3,500 tons of coal. I know how much money I get when I sell coal, so I can sort of, use that to help keep track. All right, now let's do it the other way, the final way, where we do two triangulation surface volumes, and you're going to see that this is going to match. Now, pay attention here. Right up here at the top, it says select the existing surface. So that's going to be my base. That was the existing ground before I put my pile down. I'll choose open, and it's going to come right back to this again. So if you're not looking at this up here, you're thinking maybe you didn't pick the right surface, but now it wants to know the final surface. So I choose the top and I say open. So now no inclusions and exclusions. Keep everything the same there. And we'll say, okay, I'm going to put this one out on the screen, and we'll just go over here to the side, put this one down now. And I'll exit or edit this same. Deal, but it shows me I've got an existing surface. And I've got a final surface. So it compares base to top, but now look at the numbers. They are exactly the same, and that's what I would expect, because this method of one volume using the perimeter base of that 110 surface was exactly the same as the surface I made using the base. So either one of those two approaches is the right approach to get you the right numbers. Okay, so see how that part works. Now, obviously, you're going to do more than just, you're going to do more types of volume comparisons than just stockpiles. You're going to have an existing ground like that entire aerial mapping that you saw before, and maybe you're building a new parking lot. That's your final surface, and your existing surface is that existing ground. So that's going to, it doesn't matter that this is a stockpile, is what I'm getting at. Now on the civil menu under surface, there are some tools called stockpile and pond and pit volumes, and they do the exact same thing. They come up with the same numbers. This is just extraneous stuff that you don't really need. It just sort of helps some people visualize their workflow a little bit better. So we've got everything we need right here with what we've been doing. Now, we built our surfaces. We've got the perimeter. Go back over here. We've outlined, we've drawn that, closed polylines, and you could and here we compute the volume. This is going through that same explanation there. The one triangulation method versus the other. So now we're going to put in a pit. But so the first thing let's do though is let's go ahead and contour our surface. And beyond that, I'm going to also I'm going to erase everything. I'll leave that outline there just for reference. But I'm just going to erase those points. They're still available to me, but I don't need them for anything right now. So I've got a surface. I want to contour that surface. Remember, that's on the surface menu, contour from tin file. Now remember, when we did triangulate and contour, you had the option to contour while you do the triangulation, but I didn't need to because I've got the surface saved. So I'm going to contour from tin file. I'm going to choose my top. And There's no need for inclusions, exclusions. If I uncheck that, you're going to see that it stops at the edge anyway. And let's turn the contouring on. And this time you see I've got a CTR intermediate, CTR index. I'm going to go 1s and 5s. And let's look at the labels. I'm going to draw my labels on contour label. And I'm going to set the size to be 0.08. That's 0.08 of an inch, remember, because it says scalar, text size scalar. And I'm going to come down here and say label the index contours only, align with the contour, draw on the real Z, and I'm going to hide the drawing under the label. We'll see why in a minute. And I'm going to turn this button on now for how to tell it how often to draw those distances along the contour. So over here, my scalar, remember, plotted inches. So if I want this to drop a label every, say, 3 inches, I think that will work for us. Let's see what happens. There they are. So I only get the 1. All right, well, let's try that again. I'm going to edit, erase by layer, select from screen, and I'll just include the text, the index in one of those. And let's try that again. Contour from tin file. We choose the file. And let's change, apparently that number there didn't have the effect I intended. Let's go every, say 50 feet. I'm also going to tone down the size of those a little bit. I'm going to make them 0.05, just so they're a little smaller. I'll say okay. And there they go. Now that's a little too close. I'll erase by layer one more time and just hit enter. It was the same thing. I'll repeat that layer, or that command rather, sorry. And this time, instead of every 50 feet, let's go every 200 feet and see what that does for us. And I see I've got 1 there, 1 there, 1 here. That one's too small to label. Once more. And that was just a little too much. So let's try it one last time. And let's go every 100 feet. There we go. It's a little bit more what I was looking like. So now we've got that done there. And we've got some inconvenient spots for those labels. They're on those sharp corners. So we need to sort of think about rearranging those. And there's a command to do it. You could just pick it up and move it and rotate it and all that, but there's an easier command on the surface menu, contour utilities, and we go over here and choose move label along contour. We choose that. We choose the label. And then notice as you move the cursor around, it walks the contour. So you can get in a spot that looks, that looks like a good spot for it. So notice it hides the stuff underneath it because there's a wipeout that's associated with it. I'll do the same thing with this one down here. I'll put it up there. It's a little bit better place for it. Same thing with this one. You might bring it up to here. And this one, I might want it to be a little more out in this direction. Over there. Okay, maybe. And you could even maybe just get rid of one if you don't like, if it's too many. But that's okay. That's good to go. Now, you've got these. They're rather sharp looking. We talked about that. And there's a triangle edge that runs right down that nose. You could go to fix that if you wanted. But again, we don't have any real evidence to tell us that's the right way to approach it. So we'll leave these as they are. You could go to your contour utilities, and I think there is a thing here that you can smooth the contours. I don't. Oh yeah, right here. If I smooth the contours, and we just take the default Bezier smoothing, that should be okay. Let's see what happens. We'll say okay, and it wants to know the entire or just a section. We're going to say everything, what method, the least curvy, the most curvy. So if I pull it up here a little bit, give it a little more curve to it. And I'm going to uncheck the reduction. I'll say okay. And I'll say select the ones I want to smooth. I'm going to select all of these, but then I'm going to hold the shift key and click that boundary. I don't want to change that one. And so I do that. Contour interval was 1. And you see, wow, that blew that up right there with that. It looped it around too much, you see. So I'm going to undo that. Maybe repeat the smoothing. And let's say, let's not use a BZA, let's use a, maybe a cubic B spline. Let's see what that result does for us. Now, again, I wouldn't be spending a lot of time on this myself. I'm going to shift click that. I'll get that out of the set. And now you see what that did is it smoothed everything out. So maybe that looks a little better. Okay, but it didn't change the surface at all. All right. Now, you could also do that if I erase by layer, just get rid of everything again. When you go to simply draw the contours, when you draw, let's see, contour from tin file, like we did before. This time on the contour tab, I'm going to say, use Bezier smoothing, but instead of being jammed all the way up, I'm going to pull it back to the middle here a little bit. And now that looks good. I'll say okay. And now there's a nice smooth looking surface. I'll reposition those labels again. Contour utilities, move label on the contour. I'm going to move this guy up to in here. I'll move this guy over to here a little bit. That one's okay. This one's probably okay, but I'm going to move him anyway just to get him off that corner. And I'll bring this guy back this way a little bit more toward the outside edge. All right, so I'm happy with that. And that gives me something to work with as an existing grade. I visually see it in good reference. Now, to help with their final map output, let's change a couple of things. I'm going to go to my view layer control or use that button next to the pull down up here. And now those were drawn on these layers, CTR index, CTR intermediate, and CTR inter-CTR label. So it really got misnamed. I didn't get it set right in the dialog box. I'm just going to rename these. I'll call that CTR label. I'm going to put an EG dash in front of those. EG dash and EG dash. And I'm going to change some colors. So I'm going to control click these two that have the index and the label. And I'm going to change that color to this sort of light gray and say, okay. And I'm going to give it a weight, a line weight of say 20 or 0.2 millimeters. Now my intermediate contours, I'm going to change to this slightly darker shade. And I'm going to set its weight down to 0, the minimum that it can have, right? So now when I look at that, you know, I see, okay, there's how they're going to look. Maybe you want to do a little bit bigger on this. We'll just go to 25. All right, so there now you can see nice existing contours, but they're still solid contours. One of the things that we typically see, and that's a little bit too big for my preference. 30. Let's put it down to there. All right, so a couple things that if you look at these line types on those layers, I see that they're all set to continuous. Well, I could use these two dashes, or I'm going to hit this load button down here to load up some more line types. And I'm in this one called ICAD.line. If you have to browse for it, I think it's the default for you anyway. And you can scroll this thing down until you get past those numbers and you get to the C's, and you want to look for, if you have, contour and contour 2. So I want to load those up. Now you see you've got all kinds of other things in there. Okay, but those are the two that I want, the contour and contour 2. I'll say, okay, and now I have them in my list, and I'm going to use contour for my index ones. That's a longer dash. And I'm going to use for my intermediate contour 2, which is the shorter dash. Okay. Now I look at that and I look at a couple of things out here. Well, the dashes are way too big. So there's some things going on. When I set, or somebody set this drawing up to be 50 scale, it did this automatically over here. Well, I'm going to change that back to 1. I want my overall global line type scale to be 1. And now that makes this come into, you know, a real tight spot here. But that's if it's at a 1-to-1 scale. If I change my annotation scaling to 50, well, it blows my numbers all up. Let's put that back to 1-to-1. So there's another couple of things to look at. If I've got a variable called MS, it's model space LT scale. And right now it's off, which means it's not responding to that LT scale and a 1-to-1 relationship. So I want to turn that on. And there's also, if you're doing that over in paper space, that's typically set to on, but I had this set to on all the time. And now there they are. Let's see if this text is annotative. The annotative, all right. So if I select that text, let me see if I can select similar and use just the text. It is annotative, but I want my annotation scale to be 1 inch equals. Let's make it a 20 scale drawing. Let's say 20 scale, except I need to change this to be 1-to-20. They're huge. So if I select similar and just get the text, they are annotative. It's a 1-to-20 scale, but in paper space, I want that to be 0.08 inches tall. And so now the dashes are better, the numbers are back down, and I'm going to now select the contour lines. The dashes are still a little big for my liking. I'm going to select similar. I'm going to go over here to my line type scale and type that as a 0.3. So now that looks good for a set of existing contours. Okay. So just a couple things, and this is just cosmetic at this point, what we've been doing. Well, that's fine, but that gives us a nice little reference set. Okay. So now let's design our borrow pit. And what we're going to do is this. We're going to let's see that, design that. 394.5. Okay, so we're going to draw us a little boundary here. I'm going to go to my draw menu, and I'm going to draw a 2D polyline. And I'm going to set that, well, no, we'll just leave it at 0. I'll show you how this works in a minute. And I'm going to put this on a layer called borrow pit. It's going to create that layer, doesn't exist yet, so it'll do it for me. And I'll say, okay. And now I'm going to turn my snapping off so I don't snap the contours in here. I'm just going to draw basically something that looks like that. Okay, so I'm going to say maybe starting here, go toward this edge, maybe come down to this edge a bit, come out, close up here, and then let's just type C to close, and then you can manipulate that around if you want. Let's see, maybe let's make it a little bit bigger. Now, what's going to happen if I'm going to do this? What my overall goal is going to be here now is I'm going to set this at an elevation, and then I'm going to tell it to go out and find the existing ground on the outside edges. So it's going to figure out how much cut and fill, you know, how to make the banks to make that happen. So you don't want to be so close to the edge out here that you run off the edge. Okay, so you need to pay attention to that kind of thing from time to time. And if it messes up, then you just move it and change it around. All right, so we now have this borrow pit. I'm going to go to my layers, and that borrow pit I'll make a cyan color just to differentiate it. And now I'm going to run a command on the surface menu that says design pad template. And that's going to be what lets me set the elevation of that bottom slope, that bottom boundary. And it's going to tell it to go out and seek the existing surface at a particular slope. So if I choose that design pad template, I've got several things to look at here. First of all, what do I want to use as my target? I'm going to use a surface file. I've already made that file, so I'm going to use that. I could just have it target things that are drawn, or I could go to a set elevation. And that's useful is if this is going to be my outline of, say, a pond, or even if that's the top outline of my borrow pit, and I know the bottom elevation that I want it to be, it's going to go down until it hits that elevation and create a level surface there on the inside as well. Okay, so those different options. Now, which direction? Because this is closed, it needs to know, does it go to the inside or to the outside? Well, we want it to be, we want this to represent this bottom edge of that pit. So it's going to need to slope to the outside to catch my surface. So I'm going to choose outside. Otherwise, if you're doing if you drew the top outline first and you're going to the inside with your cut, then you would go to the inside, obviously. So we'll choose it to the outside. We're going to use slope ratios when it asks us. We're going to put in like 3:1, 2:1 type of slopes. And you can have these merger things, different colors for merging, and we're not going to worry about merging at this point right now. And we're going to say, you could use a slope pad design. So if you needed to slope this, you know, down to a corner to say, you know, to be able to drain this, you could give it a slope. So let's go ahead and do that. We're going to say use a slope pad design, and I'm going to put in there a -3%. So I want it to drain down, and I'm going to have this thing drain from this back corner down to this corner. You'll see when we do that. Okay. Now you can do just like triangulate and contour. You can have this calculate earthwork volumes and pad surfaces and all that kind of stuff all at the same time. But what I like to do is to get the thing to draw this stuff first, verify it, look at it, make sure it's what I want, and then I'll build a surface out of that stuff individually. Okay. So any of those ways. Now, these side slope polylines, those are important to draw on there so you can visualize your design and see what's going to happen with it. And I'm going to color them. So when you color them, you're going to get blues and reds, and the blues represent areas of fill, the reds represent areas of cut. This box appears to round the exterior corner, so when it gets out here, it's going to round that off smoothly instead of making a sharp corner. So I will turn that on as well. And how often do I want to draw those side slope lines? I'm going to go just every 10 feet should be sufficient. And the corner delta angle is when you see these lines get drawn, they're going to be drawn perpendicular to that outline. When it gets to this corner, it's going to draw them perpendicular to this side. Well, to sweep through the corner, it's going to go through 10 degrees of rotation until it gets around that 90 degrees. So that should be about sufficient. Shrink and swell, I'll leave it 1. No subgrades, no topsoil. Trim the existing contours inside the pad. If you said yes, it would take that pad and it would clip out these contours that go in the middle. Actually, it would take the footprint of the daylight line and trim these out. Well, I don't want to do that. I want to leave them like they are. Okay. And so now you need to tell it, what does this go, what layer do I want to put this on? I'm going to put this on a layer called pit. That's just my borrow pit. Even though that's on my borrow, that's on a separate layer. Doesn't have to be, but I'm putting it that way. So I'm going to say, okay. So now it says, well, pick the pad polyline. Well, here it is. Pick the surface that I'm going to, my slope target. So it's this one, the top. Now, in cases of fill, what kind of slopes do you want? Well, let's try a 2-to-1 right now. That should be sufficient. What about if I'm in cut? I'll say 2-to-1 as well. It's there in default in the bracket, so I just hit enter. And now it's telling me, it's looking at that outline and it's looking at the surface that I'm trying to intercept. And it says, all along that line, you range from a low elevation of 395.11 to 402.36. What do you want the bottom elevation of this thing to be? Now, if I were putting this there as a building pad, I might say I want that to be at 400 or 401. So it's somewhere sort of in the middle. So half's in fill, half's in cut. But I know that's going to be all down under the ground. And I think, what did we say this was out here? 394.5. Whoops. So 394.5. So I'm going to say, even though that's below the bottom of the existing grade, that means everything's going to be down in the ground a little bit. So I'm going to say 394.5. And we'll hit enter. Now it wants me to pick the first point to define the slope direction. So I'm going to come from this back corner here, and I'm going to slope it in that direction at 3%. Okay, and so now you notice that my intercept out here stayed within that boundary out there. Okay. So do you want to adjust and redesign? If you say yes, it steps you through those questions again, different side slopes, different things like that. So I'm not going to, I'm just going to accept this, say no. And now all I've done at this stage is drawn this stuff into my file. So let's take a look at how that looks in my viewer. So I go to my view menu, 3D view, drawing viewer, and I'll just select everything. And I'll bring this up and I'll spin this around, and I'm going to see that, yep, indeed, that looks like what I mean to do. I'm going to cut that pile down to match that. Now I've got to fill this up a little bit here. So maybe I want to drop that down to be a little bit lower. In fact, I think we will. So to be able to do that, you would, so I see that 394.5. Let me see what this is here. This is Let me get this out of the way here a little bit. All right, so if I hover in that grip, it's 397.67, and that's 394.5. Okay, I drew the direction in there incorrectly. I should have gone the other direction. So I've sort of not done this correctly. So to be able to fix that pretty quickly, because this is an iterative process, I'm going to go to my edit, erase by layer. I'll clear that, and I'm going to select from the screen. I'm just going to pick one of those lines because that was that pit layer. And it clears all that out, and it leaves me with this, which is still the original at 0. Okay. But this time I'm going to set it to be, instead of 394.5 and then putting that direction this way, I'm going to put my direction the other direction. So I'm going to go back now. I'm back to where I started. Surface, design pad template. I can leave everything like I had it. I'll say, okay. Now there's also a place down here where it said erase previous pad right in here. I could have had that on there. I would not have had to gone up there and say erase by layer, but that keeps me from accidentally getting rid of something that I like. So anyway, I like this now like it is. I could either make this a positive 3% and then use the same direction, or if I leave it as -3, I'll say, okay, I'll put this in. I will select my surface. I'll keep the 2 to 1s. And now I'll keep that 394.5 just like I had it. But this time I'm going to go from here to here. And so now it's all in cut. That's a little bit more of like what I expected to see. I'll say no. And I'll verify that by selecting this polyline. I'll hover here, and that should be my low point, 394.5. It is. I'm looking down here in my coordinates. And I come up here, and then that is the 397.67. And if you want some confirmation there, here's a quick way of doing that. I'm going to draw a 3D polyline. Doesn't matter what layer. I'm going to go from this corner. I'll turn my snapping back on. So from that endpoint up to that endpoint, and that should be something close to that 3%. If I want to know what that is, I go to my inquiry. I look at my drawing inspector. I turn this, right click and turn these things off. And I just want to look at my polyline data, and I hover over there. And then I draw a 2D poly. No, it's a 3D. Let's see. I snapped to the incorrect. See what it snapped to? It snapped to the original 0. So I'm going to fix that just right here. I'm going to grab that grip, and I'm going to come up here and put it here. And I'll take this one and put it up here. And then I'm going to go back to my top view. Now, when I hover over that, you see that slope says 3%. That was what I was after for a drainage. And if I also show the direction, so that means it goes positive 3%. So it climbs from the low point there at the outside corner down here. It runs uphill toward that back corner at a 3% slope. That's exactly what I was after. I'll turn off my inspector. I'll select that, get rid of it. And now my text is looking goofy. What is going on? I select similar and choose just the text on the paper text type. I don't know where and how that got changed. Somehow it did as part of the result of that one of the commands that I may have interrupted. So anyway, I fixed it back. So now if I look at everything in my 3D viewer, even though I didn't notice that it sloped the wrong direction the last time, but I did see now I'm cut down into the ground. Okay, so I'm in good shape. Now, what do I need to do is I need to isolate this pit layer and build a surface out of it. Okay, so I can work my way around all this stuff, or I can come up here to view and let's isolate layers, and let's just pick one of those side slopes. And there again, you see, if you needed, you could come back and, you know, do a little examples of what's going on. But this is my bottom at 394.5, but it climbs up at a 3% slope, so I can drain the water out of it, and it intercepts my existing stockpile at this outside edge, with these side slopes being 2 to 1. Okay, so I want to make a surface out of this information. So what do we have when we make a surface? We want an outside inclusion boundary. That's that outside edge. And then we just select everything that has elevation, and that's everything you see in here. All of that line work. I don't need any points, because the points it's going to read from it, from all of these vertex locations, all of these, and create a surface from that. Okay. So let's go to the surface menu and choose triangulate and contour. And this time I'm going to uncheck draw contours, because remember when we said contour from tin file, it runs this same dialogue and it keeps that stuff. So I'm going to uncheck this. I don't want to draw these contours and put them on that same set of layers and such. I'm going to go to triangulate now. I'm going to write the file. I'm going to select, and this time I'm going to call this surface pit, my borrow pit. So I'll say save. I will use inclusion and exclusion. I'm not going to erase any previous. I will ignore zeros. I'll densify the break lines. I probably don't have to. There's plenty there. And I will say, okay, follow my prompts. I'll select my inclusion. There's no exclusions. Select what I want to use to triangulate. I'll select everything. Off I go. It's built the surface. If I look at that surface, let's go ahead and turn this on, and let's spin it up in 3D, and let's set our contour intervals to 1 so you can see that a little better. That's what those contours will look like, you know, once we do the grading plan for that, and you'll see that in just a minute. All right, so now you've got a nice surface. That's by itself. We can go back to the view menu now and say restore layers. If I can find where it is, there it is. And that puts everything back there. This is, remember, these are just drawn 3D lines. In my final map, I'm not going to have those draw anyway. So I'm going to freeze that information. So I'm going to go to view, freeze layer by pick. I'm just going to pick one of those. Now I can leave this on here if I want to draw the bottom of that pit. That's not a bad idea to do. I'll leave that there, and we'll keep that in our final design. And maybe, you know, we'll set up, you know, different line weight and color and stuff like that later. But so what I want to do now is let's do a quick peek at the contouring. So let's go to surface, contour from tin file, and let's contour that pit surface only. Now, again, I don't need this inclusion or exclusion. I can uncheck it. I go to contour. This time I do want to contour. I'll draw one, and I'm going to put these on some new layers. I'm going to say select, and I'm just going to type down here BP for a borrow pit, dash CONT, or let's call it CTR dash INTER, intermediate contours. For my index layer, again, keeping 1s and 5s, I'm drawing the index, I'm going to select, and I'm going to call that one the same thing, BP dash CTR dash INDEX. I'll say okay. I will turn smoothing completely off for that one because it's nice and well defined. I'll go to labels. I will label here. I'm going to select again, and I'm going to type this one to be on BP-CTR-LBL for label. Now it's going to build those layers for me. I'll worry about the colors and such here in a minute. I'm going to go to label the intervals if I want to. Let's just say 1 per contour, but it's going to be index only. So that's all well and good. We'll say okay. And boom, there's the contouring that goes along with that borrow pit. I will now take this contoured utilities. I'm going to move this label up to here. Yeah, I see that one there. And one thing I might would have rather done is, let me see, select this. Oops. I want to select that text, this text, and choose the text only. Instead of it being 0.12, I'll also make that 0.08. But I'm going to change it to standard. And then I'm going to go to my Explorer, which is the same as layer control, choose text styles, and for standard, I'm going to set that to be, no, let's just use Arial. So now I can differentiate the differences in those contour labels. And then finally, I will change the colors. I'll leave the indexes as red. I'll turn my intermediates as yellow. And then when we plot it, we can make them be different colors. But right now, that's what that would look like as a grading plan. So if I go over here to my, let's see one thing, let's set my weights, my index, and we'll make them heavier. My intermediates, I'm going to make it about half the weight. So they're going to be a little bit of a weight on them so we can see it. And now when I go to, if I were going into this as a drawing sheet, I would get this out of the way. I would change this to be, I'm going to use my Adobe PDF. I'm going to put that on an ANSI D drawing sheet, and I'm going to use this particular print table. I will display print styles, say okay and close, and I'm going to stretch this up to be, the bigger part of my file. I'm going to make a new layer called viewports, and you don't have to do all this stuff. I'm going to show you my typical workflow, and I would have that as a color 241, but it's going to not plot. I'll see it, but it won't plot. So I'm going to put that viewport on that layer. So now it's going to show up as red, and I'm going to also get that sort of in the middle. And I'm going to set that scaling. The annotation scale is 1 to 20. I'm going to set that to be 20 scale as well. So that would be a 1 inch equals 20 feet. So I don't really even need to have it quite so large. That's basically going to be all that I would need. Reposition it, you know, wherever I wanted it to be on the sheet, and that leaves me room for notes and scales and stuff like that. All right, so that's another not really part of this class, but you can see what this is looking like. That looks like a nice little grading plan. I've got proposed contours. They're heavy, not quite so heavy, they're solid. And you see where they tie to the surface. You see this one here? If I select that, I see it has an elevation of 397.0. If I select that one, that's 397.0. So that's where that contour ties. The same thing would tie there. This one ties here. 395 is self-contained. Around the edges, 400 ties to 400. 398 to 39 or 401 to 401, that sort of stuff. So, you know, the resulting final surface is going to be walking around here. It's going to come up here, hit this, walk around the pond, and then come back out. And then it'll go across. All right, so that's part of that successful presentation. And again, we're doing it with just these intermediate surfaces. So what else can we do now? First, we can go up here and save our drawing, just in case. So now, how much material did I get out of that pad that borrow pit that I just made? Okay, so I'm going to go to my surfaces and choose volumes by triangulation. I'm going to choose 2 triangulation surface volumes. It asked me for my existing surface, which is my SP top. That was my original ground. My final surface is my pit. And I don't need to worry about any inclusions or exclusions because they end at the edges. I'll take everything there. I'll turn off the tonnage. I don't need to know about that necessarily. I'll plop this down over here on the screen. And let's look at these numbers. So now that says I'm going to get 1,300 yards of material out of that. I'm going to cut 1,300 yards to get down to that design. Well, and no fill because it was all in cut. So that's what I'm expecting. Okay. It comes up with these numbers right in here as, you know, if I'm looking at this block right here in my report, that tells me my average cut depth is 3.5 feet. But these 2 numbers right here, the elevation change to reach balance is 3.421 feet. So if I raised the bottom of that pit up 3.421 feet, you should see these numbers go to 0. That's what it means by that. Okay. And then how much does it change? I get almost 40 yards out of it every 1/10 of a foot that I raise that. So if I drop it an entire foot, that means there's 10/10 of a foot. So I'm going to get 400 yards for every foot that I drop. I'm going to get 400 yards additional to that amount. Okay. So that's a way that you can help use it to refine your design a little bit. But now there's another trick to this. If I'm going to save my drawing. Now you're not going to be able to follow this part of it on your system because Survey doesn't give you this tool, but Civil does. So if I have a pit design, I'm going to switch over to Civil real quick just to show you its capabilities. I'm going to now turn back on those pit boundaries and I'll freeze these contours here. All right, so that was a pad that I designed. And on the surface menu of Civil, I've got that same command, design pad, but I can now edit the pad template. And if I do that, it wants me to pick the original pad polyline, which was that one. And it shows me over here, okay, I use 2-to-1 side slopes and I have a bottom elevation of 394.5. Now watch what happens with some of these changes. I can move that pad. And if I do that, I'm just going to pick the whole pad up and move it from there to say over to here. And then I'm going to come over here and I'm going to say process, and it's going to recompute everything that we did before. Okay. And that tells me, if I look at my report, I see that, okay, that gives me, where's my cubic yards? 900 yards of cut. Well, that didn't help me do much. So I'm going to actually, I wonder if I undo that, will it go back? Yep, it did. It will. Okay, now it's back. So if I'm going to exit that and just repeat the command. Choose my pad. And there's the original things. Now, let's say that was my initial guess at an elevation. Well, let's say I had what, 1,300 yards of cut. What if I needed 2,500 yards of fill over here on another part of my construction job? And this is, I'm just designing this to tell it how much I need to figure out to get over there. Well, if I need, instead of 1,300, if I need 2,000, I can fix that right here with this balance button. I can say balance, and your typical balance means balance, like if I'm building a house pad, I want equal cut and equal fill, so I don't have to haul anything in and out. But in this case, I want to be able to carry out 2,000 yards of material. So I'm going to put that in my export and I'll say, okay. And it says, do you want to find the optimal slope percent grade? I'm going to say no, I'm going to keep it at 2-to-1. And so it redesigns and it drops. See what it did up here? It dropped the bottom elevation to 392 instead of 394.5. And if I look at my report, I see now I get 2,000.08 cubic yards of cut. So I now have my required volume. And at that point, you can just write the 10 right at this point, or you can go back, isolate the layer, build your 10. But if we just write that 10, save it. Yes, I want to replace it. There it goes. And it contours. I'll exit that. I'm going to fix those text labels again. Let me see, let me freeze the actual pit layer. And now I'm going to erase by layer, clear that, select from screen, get the text. And I'm going to go back again now to contour from 10 file. Let me switch back to survey now. And I will contour from 10 file, my pit. Everything's good to go there, except I wanted to put these. Equals down to 0.05. That shouldn't have been so big. Let me see what's going on there. All right. When I say that, there they are. If I select the text, it's, why does it do that? I've got my scaling correct. All right, let's see one thing. I'll just clear those off again. I will contour from 10. Oh, before I do that, let me take a look up here. That's why. If this was a 20 scale drawing, that's why I switched to 2. I didn't change it up there. And symbol sizes will be a 10th. Text will be 0.08. I'll say okay. And now this should work better for me. If I contour from 10 file, I'll select pit. And this now should be okay there, but I'm going to change the style to standard so you can see that better. I'll say okay. There they go. That's the tinier size. Actually make them a little bigger than that. Put that back up to where it should be, 0.08. There we go. Now they're matching everything like I expected to see. And you see where they tie into the existing coordinates. And now we've got a condition where this pad will slope to drain. And I can put all kinds of things in here to make it drain. You know, I can dig a ditch, put all that stuff together. I've got 2 surfaces now, 3 really, at the bottom of the pad or the pile. I've got the pile itself. I've got this borrow pit. And, you know, we're getting to where now we've calculated the volumes. If I wanted to reconfirm that, I'll do volume by 2 surfaces, picking my base, or sorry, my SP top as my existing, my pit is my top. No inclusions, no exclusions. If I look at this report, you see there's that 2000.08 cubic yards. So I'm happy with that design. I'm good to go. I'm happy with the placement of the contour labeling. So everything is really good to go. Now I've got, if I look down here, you see those little things there. When it looks sort of ragged, these are extra points in here that I don't need. That's all one constant elevation. I don't need all those extra points to define that. So if you do this, edit polyline utilities, let's reduce the polyline vertices. We'll give it a 10th as a cutoff. And we're going to just reduce everything, including the ones from the existing contours. And so now this should have a point here, and it goes all the way to a point here, and it does go around the corner. You know, because it's sort of mimicking an arc in there. You could actually, you know, come in here and dress this thing up a little bit if you wanted. It's not worth doing here. I'm just showing you that all of this stuff works because this is nothing more than a polyline. Okay, so it's perfectly legitimate to do those kind of things, but I haven't really done anything to the surface underneath that. All right. So now that I have what we're looking for here, we need to take this existing stockpile and we need to take this pit and we need to turn that into a continuous surface, because I'm going to put a road from out here into this stockpile so that we can get our trucks up there and get material out of our borrow pit. Okay, so to do that, we need to figure out how to merge this surface into this other surface, and that's on our surface menu, and these are under the triangulation file utilities right here. And we start out by needing to load a base 10 file. So I'm going to load that first one, which was my SP top. There it is. There's a little bit of some of the same controls that you saw from the 3D viewer, but there's that one. Now, that's all I need to do at this point I'm going to say next, and I'm turn that back on, spin this up if I need. Now I'm going to merge into a 10. I'm not going to add a 10. That adds an amount to this 10. I don't, it takes the whole 10 up, subtract is the same thing, but I'm going to merge a 10. And so what I want to do is I choose the type. So my second 10, the one I'm getting ready to pick, is going to be inside the current 10, which has the outside boundary. I'm going to, you can set these colors if you want to see them. That's no problem one way or the other. But if I say okay, and I'll choose my pit, there then becomes what this surface will become as a single contiguous surface, and that's what I want. I want to use that to use as the base of my roadway design. All right, so I'm happy with that. I'm going to come down here to the bottom and to the output section. I'll check all these boxes, so I want all of those pieces, and I'm going to choose save as. And I'm going to call this one EG-merged. So that's going to become my new existing ground. That's been saved. And I can exit that. I will verify that by looking at that surface in my 3D viewer, just to make sure there's the contours, that if and you can see where those contours came out and hit, and it, comes over here, walks around the pond and comes back out. So that's exactly what I was expecting to see. It comes down to this corner. I can put a pipe outlet here, and that's another day to talk about things like that. But that's the basis of having this happen. I've now created this new surface by merging these two together. All right. So now let's design our road. So I'm going to come in from over here. And I'm going to come up and turn into my borrow area. So I'm going to come in so that I don't have to climb up this steep bank here. So I'm going to design this first of all by drawing a 2D polyline. And I'm going to put this on C-road-CL. C for civil, meaning proposed civil road, because it's a road feature. CL for center line. It doesn't exist yet, but we'll let it create it and we'll go. We'll say, go ahead. Now I'm going to come from over here. Let's see, let's just snap nearest right in here. And I'm going to come up and just sort of be eyeball parallel. And I'm just going to go 90 degrees into here. So I'm just going to say, let's go perpendicular to say that contour line right there. Maybe, I don't even know if I need to, because that contour line is not square to the, well, no, that is the pad. Sorry, that's the pad. So it went perpendicular in to that pad. So you might move this down just a wee bit. Nothing terribly urgent there. But now I've got the beginnings of my roadway. Well, my truck's not going to come up here and stop, make a hard left turn. I need a curve in there. So I'm going to put a fillet radius there, and it's just going to be a CAD edit. I'm going to go over to my modify toolbar, come down here and choose fillet. I'm going to see my command is asking me to select the first entity, then the next, but it tells me the line above my radius is 0. So I'm going to type R, and I'm going to put a radius in there of, let's say, at least 15 feet. That may be too big. Let's see. So if I select this and then this, no, that'll be fine. A 15-foot curve. Now it's still probably a little tight for a haul truck, but you get the idea of what we're doing. Now, I'm going to now turn that into a center line file. So I'll go to my centerline menu and I'm going to say polyline to centerline file. And I'm going to call this Hall Road. I'll save, I'll pick this, and it tells me down here, the polyline should have been drawn in the direction of increasing stations. And I did draw it in that direction. And it shows you the direction, and you have the option down here to reverse it in case it's backwards. But I'm happy with that. I'll just beginning station of 0 + 0. I'm good with that. I'll say enter, enter to finish. So I've now done that. It's its own, it has been turned into a center line file. I can now go to that layer, C road center line. I can change it, load up a center. Let's load all of these. Centers. And then decide which one we want to use. Let's see, finer short dashes than center. And we'll just leave the default width. And that's what our center line would look like. We plot it, we can put the stations on it with this station, the polyline center line. We'll leave them off for right now, but you get the idea. Now, all we have is a 2D line. We don't have any indication of where it is. If I look at it here and I zoom up, see it's still at 0, as is my original boundary pad. But I need to make that into a road design that has a profile on it. So to real quickly step you through this, and I'm going to leave this to your own exercises later as well. When you go through this part of the book, you're going to see in here, and you see how we've done those contouring just like we've gone through, and here's our little center line. We had a little extra curve in it, and we're going to design the profile. Now I'm going to whip through that pretty quickly and show you the steps, and I'm going to let you go through the stepwise at your own pace. But so I'm going to go to my surface menu, and I've got down here some profiling tools. So I'm going to create a profile from a grid or triangulation surface, and that's going to be my base surface here. That's going to be my existing ground. It'll be a roadway type. No offsets. I'll go okay, and I'm going to call that one Hall Road dash E. Oops, let's spell it right. Hall Road dash EG for existing ground. I'm going to choose a centerline file to use. Here it is. It's now made that profile. You don't see anything there, but if I go back to surface and look at my profile editor, I look at that Hall Road profile, and that's what that existing ground looks like along that center line. Okay. If I look at it as well from the surface menu quick profile, I'm going to use a surface file, and that's going to be that EG merged. And well, let's see, let's use the EG merged and the at the top, and then the EG merged. Let me see, is that right? No. I think this is what. And now, what do I want to do? I want to look at it along that centerline file. So I'll choose that centerline file. And there now is the red, you see, and I get right to this point here, and you can see as I'm over here, when I track along here, it's exactly the same because I just made a centerline file along the existing ground until it gets right here. And you see that white line that tracks in the profile view below? That's walking down the bank of that borrow pit. But the little red tail on it, that's what the original ground used to be, and that's where they depart. Okay, so I've got that. You can also repeat your quick profile. You can look at, let's look at the original SP top and compare it to the pit. And this time, instead of using the center line, I'm just going to pick a couple of points. I'm going to say pick from here and go across to here. And now you can see I'm tracking it along the original ground, but you see the pit elevation. So if I reverse that order, let's put the pit in the first one and the top in the second one. And again, I'll go from here across to here. And now you can see as you track over here on the right, you're seeing the stationing along that line, the slope, there's at 2.6. And you see how it compares, and it reads out the amount of, the elevation of where the thing is tracking up here now. If you've drawn it in this particular fashion, you can choose this adjust alignment and watch what happens when I go to move that alignment. See the profile view updates in real time, shows you what that would look like. So if I put it down here into that corner, and I'm going to adjust the alignment again, I'm going to move this point up to right there. And I'll adjust it one more time and take this back point and go up to this upper point. And now if you remember, when I first did this, I set that to be a 3% slope. Look over here on the right. See, I'm on that 3% gradient along that slope. So everything checks out there. All right. So I've got a pretty good design. Now, to make that road design work under surface, now the civil package has all kinds of road design tools, but we don't have that. So we're just going to go to Profile Editor. And we're going to make a new one called Haul Road. We'll just call it Haul Road Profile. That'll be my design profile. And I'm going to have an empty sheet here, but I'm going to add a reference center line down here. And I'm going to add a reference profile, which was that existing grade. So now I've got something along the same stationing as my haul road, but I've got something to design against. So I'm going to start with station 0. And I'm going to make that at 0 depth. So that's going to set the elevation down there. I'm going to look at my reference center line. It goes to 1 plus 44, 43, 53. So I'm going to call that 1, 44, 43, 53. I'm going to set that depth at 0. What happened? 0 to 1 plus 44, 43. Let's cut it back just a little. Maybe that's the problem. Let's see. This, and I set my depth to 0. Oh, come on. 43.27. Sorry. Just say 43. There we go. So my road profile right now goes start to finish, nothing in between. So I need to add some vertical curves. So I'm going to come in here and add, I'm going to insert in here a vertical curve. So I'm going to add a row. And I'm gonna go to say station. Let's go right in there. So station 25, elevation 395. So 25 at 390. Let's make it 396 just to come up a little bit. That'll be about 3.5% up. And I'm going to come over to here and on that existing ground. So I'm going to look at that station at about 0 plus 80. So I'm going to come in here, add a row. I'm going to go to 0 plus 80 as my station. And the elevation I'll put in there at, what is that, 390? That's kind of 399. All right, so that's back. Let's come back to this one and make that 395.5 just to drop it a little bit. And now I'm going to put a bit of a vertical curve in there. Let's say 25 feet to see what that does for us. It makes it there. I'm going to go to here and put that one in at, say, 75 feet, a little too much. Make it 50 feet. Yeah, it's a little smoother. And let's see, let's make this one 20. And this one 40. And then I'm going to add one down here about in this area at 123, 125. Now, again, the road design tools are a lot quicker and easier, and I'm going to set that elevation to be like 394, let's call it. And I'm going to give that a vertical curve of 20 feet. So that's going to come in and then come back into, let's drop that last slope down. Instead of that slope being at 3, let's make that 0. We need to come up here and drop this elevation. Let's make that 390. Whoops, a little too much. 397.5. That's a little bit better. I don't want it all cut though. So 398, let's say. There we go, a little better. And we'll come back to this one and drop that one down to be like 393.5. Yeah, so that gets me up smoothly and gets me down smoothly down to here. So now I've designed this, I'm going to save it. And I'm going to exit. So I've now got my design profile. So to get it into this drawing, I'm going to go to that surface menu, and down in here, I'm going to profile to 3D polyline. So it's going to read that profile design and create a 3D polyline for me. I'll say, okay. The reference center line that I'm going to use is prompting me for below. Oh, wait a minute. I'm sorry. I used the wrong command. Let's see, draw on the profile. Set the reference. This is not what I want either. All right, bear with me a quick second. If I went to my profile editor, do I have a another there? Let's see. I'm used to having my civil tools at my fingertips, and I'm trying to do this with just the survey tools. If I draw a 3D polyline, do I have an option? No. I'm gonna draw. Nope. Just do a quick profile from. I don't have a choice. Profile the points, I don't think so. All that's gonna do is create the points. Uh, You see that expects me to pick it off. All right, let's say centerline file. There's my design. Oh, no, it did that. Sorry, had it right the first time. I thought it was going to have me pick it. So now if I select this, I see that's a 3D. And if I look at that by looking at my 3D viewer, and I'm going to spin this up sort of on the side, and you can see now it starts down there, comes up, goes through that vertical curve, back down around, and comes in flat to my borrow area. So you see part of that's underneath that original ground. So there's some grading involved. Now to establish that as a roadway, I need to offset some edges here. So I'm going to make a 20-foot wide road. So two 10-foot lanes, if you will. But I can't offset a 3D polyline with standard AutoCAD offset. I have to use the Carlson version, which is this, and it's not on the offset menu here. There's the standard, but it's going to be on the draw. Edit 3D polyline utilities, offset 3D polyline. So I'm going to use this interval method, which is going to allow me to specify a horizontal distance and a vertical difference from that. So I'm going to choose that method. I'm going to say, okay. And it wants to know the horizontal offset amount. Well, I'm going to go 10 feet. And now how much of a vertical amount do I want to go? Well, I want to go, right now it's just looking for numbers, but one of my options down here is P for percent. So I'm going to say a percent. So this is the slope down from the crown, and I'm going to go -2%. So I'm going to select the polyline to offset that 3D, and I'm going to go to this side. Okay. I'm going to do the same thing, continue with that same thing. I'm going to select it here. And I'm going to go to this side. Okay. Now, I may be getting a little tight over here on the edge. So actually, I'm going to erase these two and cut that distance down a little bit. So I'm going to offset my 3D, same method. Instead of 3 to make 20, let's make a 15-foot wide road. So I'm going to go 7.5 feet. -2%. Whoops. 7.5 feet. P for percent -2. There we go. Now we go from here to this side, here to this side. All right, that's a little better for me. Now, I will trim off that and extend this one. Just for completeness. So now I've got 3 edges. If I happen to look at that in my 3D viewer, and let's give this some vertical exaggeration so you can see that the center line is actually up higher than the 2 road edges. That's what I expect. Just back to 1. And so now what do I have? I've got the beginnings of the road, but I need to tie these edges into that existing ground. Well, remember how we did the stockpile as a pad? Yeah, so select. These brooms are fun. So just like I did a pad, I'm going to do this surface design pad. And this time I'm going to, because it's not a closed polyline, but I'm still going to do the same to the side surface, but I'm going to change the layer to be road pad. And I think everything's okay. I'm not going to use the slope design there. I'm just going to say, take that and find the surface. I'm going to say, okay. And I'm going to pick this outside edge. I'm going to target my EG merged. And I'm going to go up instead of a 2-to-1, I'm going to say maybe a 3-to-1 on this time. And do the same thing for that. And now I have to tell it which side because it's not closed. And so there goes that one. I'm going to repeat it, making sure I don't say erase previous. I'll just say, okay, I'll pick this one now, target the same. Oops, sorry. Target the same, EG merged. 3-to-1, 3-to-1, and go to this side. So now, if I look at all of that stuff, and you see how it forms these triangular looking things there. If I look at that in my viewer, I'm going to verify that, hey, indeed, it's going to, it's got to cut that down. It's going to hit that bank of where that borrow pit comes down the slope. So everything looks really nice and good for me there. I'll exit that. I will then isolate the road pad, and I'm going to connect over these 2 little open ends. Actually, I think what I'll do is just shrink wrap that. Let's see, that's the original one. So if I shrink this, cross gaps, 2D is fine. And I'll grab these things. And there now is that. I need to take this out. Everything else looks fine. And let's turn all our layers back on and let's isolate. I also need that 3D polyline. This and the boundary. So now I'm going to build a surface out of that. I'll triangulate and contour that one. I'm going to call it road. I will use inclusions. At this point, I'm not going to contour it. Actually, I guess I'll go ahead and contour it now. Say, okay. I'm going to select that as my inclusion boundary. No exclusions, and then I'm going to make sure that I get those features in there. I'll say, okay, boom, it's done. I'll verify with a quick view, which was my, uh-oh. I think I just did something wrong. I forgot to, it says road. There's no inclusion, no other inclusions, no other exclusions. All of that 3D data. Road.10, so there it is. So now why did it not, am I not in the right folder? Oh, there it is, sorry. So now, when I look at that, that's going to be that road, and you see how the contours crown across the crown, they hit the edges, they go up the ditch line. So that's now successfully integrated into that surface. So I'm going to now restore all my layers, and I'll freeze off these nasty little boundary layers. Those are my contours. I'll also freeze off this pad. I don't need that anymore. And I don't need that anymore either. I've just got the center line. I could offset this just to draw the edges, 7.5 feet. This is a standard because that's a 2D polyline. I'll select those two and change its line type to just continuous. Give it a little bit of a line weight. So there now is going to be my road with my contours, but these contours don't match that contour. So what I would wind up doing is merging the road into the pit. So if I go to surface, triangulation, file, utilities, I'm going to load up my first base, which was my pit. I'll go next. I'm going to merge my road. And if I spin that up and look at it, you can see that's what I was looking for. I will now save as, I'm going to call this pit road merged. I'll say, okay, I'll exit that. I'm next going to, as a final step, erase by layer those contours they got drawn. I'm also going to freeze that. I don't need anymore. And I'm finally going to draw the contours of my pit road merged with those same layers and labels. Standard, everything's good. Don't need that. I'll say okay. And there now is the grading plan for the road and the pit into that original ground. And look at that here in my 3D viewer. I see the contours. I go to here, I'm going to add in my well, my EG merged doesn't have the road. This has the road and that merged together. And the existing ground, if I added that surface, which was my top, you can see that. If I make my top more opaque, you can see how this one would cut into that. Now, we haven't merged that one together, but we can certainly do that and merge that as a single file. You don't necessarily need to, but you could do that, and then you could limit the drawing of the contours into those different areas. Okay, so, but this is what you would normally do to generate a grading plan to get a road up that stockpile into this borrow pit. You've got your reports of your volumes. Everything's set correctly. Let me grab these. Select similar and bring it to front. Put down on the top of it. Okay, so that is the fundamentals of what you're going to look at in this regard back here. Okay, now it is now 5 o'clock. You've bravely stuck with us an extra half hour. I know you guys don't need them, but you'll get the extra time in your certificate with your professional development hours. And so that will take care of that. So, but the first thing to ask of you is, do you have any questions? I know that was sort of like getting a drink out of a fire hydrant. So I've got something way down here to get rid of. But, you know, there's some things, and you could, you know, you've got these boundaries. You can shrink wrap boundaries around things and use them as exclusion areas to not draw contours within. So if I wanted to draw the contours of this original existing ground, but stop at the edges of these contours and keep them separately, then you would do something like this. If I said surface, I'm going to draw the surface boundary, and the surface boundary is this pit road merged. So there's that. And now if I redraw, I'm going to clear this, select these layers from the screen. And get rid of those. But if I redraw that now, contour from 10, and that was the original SP top. I will this time use inclusion, exclusion. I'll come back to here and change these back to, instead of BP, to EG. EG index, labels, EG label, style Roman S, that's fine. And that distance in there of say 125 feet. Say okay. Now it asked me to pick an inclusion. I don't need to because it stops at its edge anyway, but now the exclusion, I'm going to pick that boundary that I drew. And now there they go. I will select these and change their scale down to where their dashes are a little smaller. And I can then finally get rid of this boundary that I drew. And so now you see what you're left with is what you saw in something like this picture. See how it trimmed over there? But I didn't have to, you know, the point I'm making, I didn't have to alter that surface. I didn't have to cut a hole in that surface to get the contours to stop there. I just drew the boundary of that other surface and said, draw the contours up to it, but don't go past that boundary. And so now you've got, it's sort of grading plan. Grading plans typically have the existing contour shown underneath it, but this is the overall total finished everything. That would be, you know, something you would go out there and load into your graders, your bulldozers, and have it cut that stuff out. into that as a surface. And if I wanted to, I haven't done it yet, but I could take this overall road and pit surface and merge it into this overall outside surface, just like I did the pit only, and have a total composite surface like this. So if I load up the original surface here, I go next, and I'm going to merge. This time my pit road merged into that. I'll color it. I'll look at that. Yeah, that's exactly what I want. I'll save that as, I'm going to call this one total combined final grade. It's now saved. I'll exit that. Look at that in my viewer again. Add underneath it a surface model, which is my total combined final grade. And voila, there's your finished design. Now there's a couple little tweaks. You see right here how my road crown dropped down to the edges. I didn't address how that hit the floor of this right in here. I could have taken the time to fix that. But there wasn't a great pressing need to do that, you know, for the class necessarily. But you see how the contours from the existing ground come up and they meet the future ground. Okay, and those are just the ones that are in the drawing. So everything looks good. Everything looks exactly like I want it to be. I could then go to my tools, like if I were in my hydro model and I wanted to do a runoff tracking. There's my total final grade. Let's see, pick individually. So what happens when it rains out here? If I pick a point here, it's going to run down here and come down here to that low spot. If I pick a point there, if I pick a point anywhere there, if I pick a point out here, it runs down here off the edges. This runs down and around from my road, runs down and around. From here, it runs down, jumps the edge. So you get the idea. So just various ways to verify that everything is exactly the way you want it to be. So these are various tracks of water tracking. I'll now clear that, select one of those and clear it out of my drawing. Okay. And so that should then conclude our flight. And that would be like if we had, you know, this is that same type of, this was included in your data sets. It's a little slightly different road design. But you can see those are the same types of techniques that we used. And that's that one called example one completed. Okay, so you should get some sense of some tools that you can use. Okay. So with that, if everybody is good, any questions? You ready for a weekend?
I'm ready for weekend.
Oh yeah, definitely.
All right. Well, hopefully this will give you some things to work on, to play with. We'll get you the videos and I'll get you another one. Again, my apologies for that one afternoon session. But this sort of stepped you through as this last example, and back in the book, it's this last example called putting it all together. And that started with that. You can step that through, you know, this entire process that we just went through today, or the last half of the day. Okay. So use that, you know, to help reinforce these things. Remember some of the tools that we did, like, you know, right in here, you might want to, you know, slide this around to a different spot, or if it's okay with you, leave it there. But remember, if it's something that you're trying to figure out how to do, if it involves a surface, look on the surface menu. If it involves points, look on the points menu. Okay, that's the first place to start looking. Now, one other quick thing to point out for you is some other resources here. On the help system, if you go to the Carlson manual, this has, well, first of all, let's turn this off. And if I go to surface, contour utilities, if I say edit, well, no, I need a dialog box. Let's do triangulate and contour. And I see down there, there's a help button. And so that's going to jump me in the help system to that part of the manuals. And you'll find that some of these aren't necessarily linked correctly, but you can find it in this structure over here. You've got the general commands, file, edit, view, draw, inquiry, settings, and points, and of course, help. And then there are these individual modules. So the survey module, these are the survey menu, Kogo menu, area and layout. And there's some really great tools down here for parking design and stuff. You know, that's just not part of this class. Annotations, we did some annotations, like remember the bearings and distances, and we talked about the linking. So when those figures change, the bearings and distances change with it. So you can find those, but here's something else that's really useful for you is down here at the bottom, 3 up is this area called tutorials. And some of these are getting a little dated, but you got some generalized, you know, CAD basics, how to do some things, how to navigate through the system if you're not familiar with that very well. Survey tools like entering a deed, making a plat, field to finish, laying out intersections, subdivisions, ServNet adjustments. Now here's your contouring, DTM and design. That's what we've been spending most of today on. Okay, and so that shows you some different techniques there. Calculating volumes by 5 different methods, stockpiles by layers, by 2 grid, 1 grid, by sections. Okay, so these are all really, really good tutorials, and they're laid out here with good examples, and all of the files that they have you load up and look at are included in your default installation up in your Carlson projects folder. So you should be able to open up those files and follow through these tutorials. Okay, so those are there. They're nice and handy. And then last, there's also the online training movies, and that basically just jumps you to YouTube, to the Carlson channel, and you can sort through their various playlists, different videos that are not included necessarily in a specific playlist. You can search within the Carlson thing with this button here. So just really, really good. And a lot of these are just single topics. Like here's this power tools, and he does this, he calls these like power tools in a half hour, 10 tools in a half hour, or power tool, or 5 tools in 6 minutes. You know, Gary Rosen is the little instructor there. He's a great guy, a friend of mine up in Massachusetts. So any of these kind of things can really help reinforce that, because you're not trying to learn everything all at once. You can focus in on those different things. It's a great little resource. Please don't forget about it. Finally, you've got my email, you've got my phone number. Please feel free to reach out. In fact, during class today, I got an email from somebody that was in a class about a year ago on a 3D machine control class, and he's got a problem that he wants a little help with. So, you know, that's what we do. And that part doesn't cost you anything when you just need a little booster shot. That's part of being being one of our clients. That's part of that process. Okay. So with that in mind, if there are any questions, I'll be glad to answer them now, or I will wish you a great weekend and we'll go from there.
Thank you, and have a great weekend.
Yes.
I really appreciate it, Ken. Look forward to seeing you in the survey class.
Oh, wonderful. Okay. Well, you guys take good care, be safe, have a happy and enjoyable weekend. And at least for me and BB up in the cold spots, we're going to try to stay warm. Mike, you might soon need to start trying to stay cool. So anyway.
Actually,
Yeah, that's right around the corner. Right
You
around the
got it.